We have some really exciting photos and really exciting news coming from Uranus. And today we're going to be discussing everything that was recently discovered, including some of the best pictures we have so far coming out of James Webb Space Telescope. And actually one of the reasons this is kind of exciting is because this is one of those planets that rarely gets mentioned at all. And so of all planets out there, we actually know about Uranus the least. And so in this video, let's discuss some of these new discoveries, talk about these new pictures, and also talk about what all of this means. And let's start with the most recent news, or basically the most recent picture taken by the James Webb. The picture that really highlights gorgeous rings around Uranus, presenting us with the most complete view of the entire object, including its very powerful storms that you can see in one of the polar regions. And unlike other pictures from other planets that you can probably find in some of the videos in the description, because Uranus is essentially sort of orbiting on its side, approximately 98 degrees compared to the rest of the planets, this is literally what it looks like from planet Earth. We're facing its north side, and we see all its rings directly face on. Although for scientists, the most exciting part in this picture are all of the seasonal activities in the northern polar cap. Here you can actually see a bright white inner cap along with the dark lane in the bottom of the cap itself, which at the moment have no explanation, but basically suggest extreme activity on the surface. We also finally get to see the elusive Zeta ring, an extremely faint ring that's the closest to the planet. In comparison, this was actually the first image taken approximately 8 months ago, and this was in different frequencies and did not show us as much detail. 2 of the rings here are missing. We also get to see 9 of the 27 moons around the planet, with all of them visible in this image right here. We actually even get to see some of the moons inside the rings that were previously invisible to other telescopes. But obviously the brightest moons are also the largest in the system: Ariel, Miranda, Oberon, Titania, and Umbriel. But like I mentioned, it's really the vortex in the North Pole that's the most exciting discovery for the scientists studying this planet. But the reason this spot appears so white is actually because this is a much warmer region compared to the rest of Uranus. We've actually discussed this in one of the previous videos, where this was observed using different frequencies by using ALMA telescope, and you can learn more about this in one of the videos in the description. And so basically, along with the previous image, we now have some of the best images of this planet ever produced by any telescope, showing us Uranus in a way we've never seen it before. Here is actually a previous image by the Hubble telescope, and this looks nothing alike. I mean, obviously the polar cap is still there, and the unusual cyclone extremely close to it, but everything else is definitely different. And so this new image basically shows us all of the 13 rings, with the 2 previously hidden rings in all of their glory. But what the scientists really want to study now are of course the polar caps, and mostly because this is atmospheric storms that seem to be seasonal. A single season here lasts for approximately 21 years, mostly because it takes 84 years to orbit the Sun. And so every once in a while, basically every season, this planet completely transforms. It looks entirely different depending on when you look at it. But even more intriguingly, this doesn't just happen to the planet, it also happens to its moons. And so one of the recent studies discovered something really intriguing about the moons and about something that they undergo every season. A lot of these large moons seem to undergo an unusual change we've never seen before anywhere. They basically acquire a temporary atmosphere, or technically exosphere, twice per every orbit, or basically during 2 seasons. Now this is mostly based on computer simulations and modeling, but here the researchers from the recent study assessed some of the ices on the surface of these moons, revealing that the seasonal changes here are so intense that the radiation from the Sun is strong enough to force a lot of this ice to sublimate, transforming into gas and forming exospheres on the surface. Now, quite a lot of different objects out there have exospheres, which are basically extremely thin atmospheres, and here's one example from the Moon. They actually form for very different reasons depending on the object, and in case of the Moon, it seems to be more or less electrostatic in nature and formed by the interaction with very powerful charged particles coming from the Sun. But other objects, usually icy objects, form exospheres when the ice sublimates and forms a relatively thin layer around the planet. On many of these moons, it seems to happen when it's basically just slightly warmer than usual, and very likely stays this way for many years. But once it gets colder, or basically once the winter comes, a lot of this ice then falls back on the ground and freezes once again for many years until the next season. Although in terms of the actual atmospheric pressure, it's extremely low. It's not even 1/1,000,000th of the atmospheric pressure on Earth, so basically it's barely visible or barely noticeable. Nevertheless, this seems to be a recurring cycle, and it seems to repeat every few seasons, basically recirculating some of these ices and very likely changing the surface just a little bit over time. Intriguingly, the scientists who proposed this also suggest that just by landing on some of these moons and basically walking around, the temperature from the bodysuit itself would produce enough heat to suddenly sublimate a lot of the ice around you, in essence sort of forming exosphere everywhere you go. And so that's how extremely sensitive some of these ices are, and that's of course how extremely cold it is in a lot of these regions. Then, in a separate study, we also discovered more information about the rings, and specifically that the rings technically should have been bigger, potentially even similar to Saturn. And the reason the rings are small, or the reason the rings are the way they are, is actually once again because of these 5 major moons. Their orbit around the planet seems to produce significant emission of dust from the Uranian system, essentially controlling the size of the rings and reducing them in size dramatically. And so by conducting a dynamical simulation using Uranian system, here the scientists discovered certain regions around the planet with quite a large amount of mass loss that seems to occur in just a few million years. As a matter of fact, 35% of the entire mass of the rings would be lost in just 500,000 years. And all of this just the result of the interaction of the moons as they orbit around Uranus. Now something similar happens around other planets as well, and intriguingly, this also explains why Jupiter seems to have extremely small rings as well. And more importantly, this also suggests the origin of the rings. They're not the result of some kind of an ancient impact or some kind of an ancient event that produced these rings lasting for billions of years. These rings seem to be relatively recent. They must have formed within the last few hundreds of millions of years, a result of a much larger moon or a larger object that came too close to Uranus. And so here, it's probably the result of some kind of a fragmentation of either an ancient moon or potentially an ancient asteroid that came too close to the planet and with time fell apart. This is how we believe all rings must have formed around these planets, and is basically the result of what's known as the tidal disruption, the event that slowly stretches the object, forming the rings and making it orbit for millions and millions of years, but not billions of years, as we learned from the study and similar studies before. Or I guess in more scientific terms, all of this is a result of a very specific resonance formed by the large moons in the Uranus system, although it looks like the largest moons, Miranda and Ariel, produce the most effects. The simulation here shows that, because of Miranda and Ariel, the rings are limited to a certain location. They cannot extend past 4.3 planetary radii, because this region becomes extremely unstable and nothing can orbit there without being kicked out or falling into the planet, with the calculations showing us how far a lot of the rings can extend around 3 of these gas giants. So Jupiter seems to have the biggest limitation, Uranus has the second biggest, and Saturn is able to form the largest rings, which is precisely what we observe in real life as well. This unfortunately does not cover Neptune, and so it'd be curious to find out where Neptune is as well. But I guess the biggest suggestion in the study is of course that these rings must have been much bigger, possibly even as big as Saturn's, but only lasted for a few 100,000 years, disappearing in the process. And we know that Saturn's rings are also disappearing, which you can learn more about in the video in the description. But intriguingly, something keeps replenishing some of the material in the rings, just like in the Saturnian system as well. And that something is most likely, once again, the moons. And so it's quite possible that either because of various impacts, or potentially cryovolcanism coming from the surface of these moons, a lot of the material gets replenished over time and gets deposited back into the rings, basically suggesting that this is a kind of a renewable event, with the rings not really decreasing in size as quickly as they should be decreasing. And so it's quite likely that these are still relatively old rings, possibly hundreds of millions years old as well, because it looks like after about several million years, the overall loss here decreases quite dramatically, with the overall balance of mass remaining the same. Nevertheless, it is still quite surprising how much mass loss is produced by the interaction with the moons, and how these interactions with the moons make all of the gas giants have very different rings compared to one another. And then the last discovery was from Uranus itself, and specifically from its upper atmosphere. Here, for the first time ever, astronomers finally confirmed Uranus has infrared aurora, as we always thought it did. And so unlike ultraviolet aurora on Jupiter and Saturn, or of course optical aurora right here on planet Earth, Uranus, because of the mix of hydrogen and helium, predominantly emits aurora in infrared light. And though this was always predicted, it's now been officially confirmed and observed by using the infrared instrument on top of Makemake Observatory in Hawaii, which also confirms that pretty much all planets in the solar system have aurora of some sorts. We've discussed quite a lot of them in some of the videos in the description, but they all seem to be kind of different. A lot of them seem to be produced for various reasons that are different from planet Earth, and in case of Uranus and Neptune and actually a lot of other gas giants, they do not seem to come from the sun or from solar interaction. As a matter of fact, it's currently unknown how this is formed, but it seems to be a result of strange magnetic fields present inside the planet. As a matter of fact, Uranus has one of the strangest magnetic fields out there, mostly because of the way it spins, and so because of this misalignment, its aurora are also unique and very different from anything else. And more intriguingly, the observations of these aurora potentially explain the unusual heat spots visible in various regions in the atmosphere of Uranus. It wasn't actually clear where these hotspots came from, with many being hundreds of degrees warmer than the atmosphere, but now this seems to suggest it's most likely from aurora, with all of this heat being pushed toward the magnetic equator, circulating the atmospheric layers in a way that's very different from other planets. But the thing is, to learn more about all of this and to basically understand this in more detail, we have to have a mission to Uranus. And luckily, NASA is sort of planning one at some point. It's not going to happen anytime soon, but at the moment, maybe in the next 10 years, we might hear more about this, because in the last survey of planetary science and astrobiology, scientists highlighted that the mission to Uranus is basically #1 priority. Now, NASA hasn't confirmed anything yet, but it might happen. Although if it does happen, it's most likely going to be mid-2030s. So I guess 10 years from now. Which means that you're going to be hearing more about this from a much more older Anton in the next 10 years. In the last few weeks, there have been some really cool discoveries in regards to ancient black holes and how they might have influenced the growth of galaxies early on, with some of these discoveries once again being potentially groundbreaking and somewhat unexpected. And naturally, when it comes to unexpected strange discoveries, nowadays it's always James Webb. And so essentially, James Webb Space Telescope once again discovered something nobody expected, potentially helping us understand how early galaxies evolved and why we're seeing so many different things nobody expected. And so, hello wonderful person, this is Anton. Let's talk about these new studies and new discoveries, and what all of this means when it comes to galactic evolution and the early universe. And I guess let's start with the more exciting study that was just released a few days ago. In this case, one of several studies that took a look at these really distant red dots and a variety of other shapes and colors that were discovered in the last few months by the James Webb. We've actually discussed these in some of the previous videos in the description, but we finally have some analysis and exciting explanations for what's probably happening here and what exactly we're seeing. And so we obviously know that these are some of the earliest galaxies, but what was really surprising about these galaxies is how extremely bright they appeared. Their overall brightness was a little bit higher than expected. And this actually led to a lot of speculations, with most scientists agreeing that this was very likely a result of a really massive black hole, forming some of the most active regions we've ever seen in any galaxy, but in this case extremely far away. Something that we definitely do not see in any of the modern galaxies, and something that seems to have been unique to the first few 100 million years right after the Big Bang. And there's a reason why this is actually kind of exciting. Previous simulations and previous assumptions have always focused on galaxies growing in a very kind of orderly, slow manner, assembling over millions and even billions of years, gradually growing larger and larger by absorbing gas from the outside and also by basically growing the black hole in the middle. And so this process that was simulated many times using various supercomputers, such as the one you see right here known as the Illustrious project, kind of showed us that galaxies for the most part seem to grow relatively slow. And that of course includes their black holes. Now, once in a while they might get some growth spurts, but overall it's not really that dramatic. Yet that's not at all what we see from the James Webb. All of these recent observations show us a lot of chaos, a huge amount of activity, and more importantly, a tremendously massive, powerful black hole right in the middle, with some of these galaxies producing way more light than expected. And we'll discuss this in a little bit more detail in one of the recent videos in the description in regards to new analysis of the famous galaxy known as GNZ11, a galaxy that's way too bright, much brighter than it should be, approximately 400 million years after the Big Bang. And here this black hole is way too massive, approximately 1.6 million masses of the Sun, which makes this really difficult to explain. And it's not just massive, it's also causing the entire galaxy to become extremely bright, much brighter than anything around it, which overall confirms one important hypothesis, the so-called direct collapse model, which suggests that it's quite likely that early massive black holes didn't actually start from stars or from some other means, but were created through direct collapse of a lot of gas all at once, forming massive black holes right in the middle of a lot of other gas. And that was basically the seed for many different galaxies. These direct collapse black holes started a process that eventually formed modern galaxies and eventually formed the universe as we know today. And so it was not a slow, methodical process. It might have been an extremely fast, extremely chaotic process that was much, much faster than anything scientists believed before. And because a lot of these early galaxies were also much richer in gas, this presents us with a very different environment. Because it's really this extremely high density that didn't just allow for these black holes to form, it also allowed for a massive star formation that turned these early galaxies so extremely bright. But previously, it was assumed that these powerful black holes would then cause these galaxies to basically die. They would stop forming stars because of the galactic wind, and they would eventually become quiescent. This was kind of difficult to explain though, because it's not really what we see in modern universe. We do see these large galaxies with a lot of stars, so something doesn't add up, with this new study potentially explaining everything once and for all. Which came first, supermassive black holes or galaxies? Yeah, so I guess it's that chicken or the egg question. And this is a really intriguing study because they do provide a lot of evidence and a super interesting explanation, to some extent summarized in this picture. Early on, in the first few hundreds of millions of years, it actually looks like the galaxies and the black holes had a very different interaction from what we believe happened afterwards. At first, at higher redshifts, up to 15, this is where we see gas suddenly collapsing into a central region and basically forming these overdensities that eventually become seeded supermassive black holes. And because there is already gas around them, they suddenly start something really incredible. Because suddenly there's this really dense, really massive object in the middle, it starts to churn the gas around even more and creates a huge amount of overdensities around it, basically creating a kind of a positive feedback for the formation of a large number of new and possibly really massive stars. Possibly even these mysterious population 3 stars we still haven't seen. And so these massive black holes that formed around the same time as first stars basically worked hand in hand, promoting star formation and star growth just because there was so much gas around them. As a matter of fact, they might have been amplifying the effect of star formation by a tremendous amount. Without these black holes, the star formation would have been much more timid and unlikely to produce these very bright galaxies. And so this positive feedback or this amplification effect was very likely the reason why we're seeing so many extremely bright galaxies out there, which also of course implies that it was the massive black holes in the center that also very likely produced some of the first really massive population 3 stars. But even more intriguingly, the star formation itself would then also increase the amount of gas entering the black hole, thus allowing the black hole grow larger and larger and larger. So this was an intriguing double positive feedback, a kind of an interplay between the black hole and the newly born stars that encouraged growth for at least a few million years. And that of course explains why we see this and so many more. As a matter of fact, it pretty much explains all of these observations really well. But after about 1 billion years of doing this, the galaxy would reach a density state that's not really conducive to positive feedback. And so it's at this state that it sort of enters the next stage, the negative feedback, where the active black hole in the middle instead starts to actually deplete the gas and forces the galaxies to become quiescent as we've always believed them to become. This is pretty much what we observe from a lot of quasars around this time. And so basically here the galaxies go from a highly enriched stage with a lot of dense gas around them to the stage that quenches star formation and encourages negative feedback that to some extent kills the galaxies completely, with most of this negative feedback caused by powerful winds that eventually drove the gas out of the galaxies instead of causing the gas to form new stars. With all of this very likely just being the matter of gas density. If the gas is not dense enough, it kind of just flows out of the galaxy without doing anything. But if it's really dense, like it was in the first billion years, it creates a lot of regions around the galaxy where stars suddenly form all at once. And so here the researchers propose a new timeline. Because by looking at light spectra and different chemical signatures from many of these distant galaxies, they discovered that this unusual shift very likely happened 13 billion years ago, or roughly around 800 million years after the Big Bang. But in order to prove this, or in order to make this an actual theory, researchers believe we still need to have computer simulations that would be able to directly explain how all of this happened. Right now, current simulations are just a little bit too simple, and so it might still take a few years for all of this to be confirmed. But since previous studies also confirmed that many of these early galaxies did actually have really massive central black holes, very often with masses equaling the total mass of the entire galaxy, at least in terms of observational evidence, it seems to be there. And so basically what all of this means is that it was really the massive black holes that very likely influenced most of the galactic formation, most of the star formation, and created the galaxies as we know them today. But even though this is a pretty good explanation for what we've seen so far, there's still a bit of a problem, and actually from a slightly different study. A problem of not really seeing enough of these black holes out there. Now this is based on a slightly different study that mostly focused on differences between previous observations from the Spitzer telescope with the observations from the James Webb, but in a nutshell, when comparing three different telescopes, MIPS on the left, Spitzer in the middle, and James Webb on the right, the researchers surprisingly discovered that there was actually a kind of a lack of rapidly growing supermassive black holes in the early universe. Now previously Spitzer did discover quite a lot, and so the scientists actually expected to find even more with the James Webb. But when they compared Spitzer to James Webb, unfortunately, even with a huge boost of power from the James Webb, they only found very few additional supermassive black holes compared to what they expected to find. Or I guess more realistically, they just found a lot less active galaxies, with many other galaxies potentially just growing much slower and thus being completely invisible. Which is very intriguing because it suggests a much slower pace for most galaxies compared to some extreme examples. Which in essence suggests that even though we might have figured out how some galaxies grow and how they develop and how black holes interact with stars, average and smaller galaxies, and more importantly, galaxies similar to our own, the Milky Way, still do not have a very good explanation for how they evolved and how they formed, especially since the black hole in the middle of our own galaxy for the most part seems to be kind of small. And so if our galaxy did not grow like some of those other ones we've discussed a few minutes ago, then how exactly did it form and how exactly did we get so many stars? If the black hole in our galaxy was never active, then that first idea behind galactic growth and black holes suddenly doesn't make sense once again. And so yeah, there's still a major mystery. Hello wonderful person, this is Anton, and today we're going to discuss some of the new and somewhat unusual and actually quite unexpected discoveries coming from various locations in the Kuiper belt, the location where Pluto is. And specifically, we have some really intriguing discoveries from two very famous dwarf planets, but also discoveries that actually surprised everyone. But I'm gonna keep that one for the end, mostly because I want you to watch the whole video. Anyway, let's actually start with something coming from the New Horizons probe, because here we have a discovery that sort of confirms what a lot of New Horizons scientists expected. You can actually learn more about this in one of the previous videos in the description, where we talk about the possibility of this mission being cancelled, but in the end, not cancelling it was actually a good move, because a lot of data coming from the mission seems to suggest one of two things. Either the Kuiper belt is much larger than we originally thought, or there might be two Kuiper belts, and the mission has just entered the second one. And that's because data coming from New Horizons keeps producing observations of an extremely elevated amount of dust, much higher than anyone expected if this was not Kuiper belt. Or in other words, it just keeps seeing more and more tiny particles, usually associated with various massive bodies in this location. And though technically it should have already left Kuiper belt a long time ago, here's roughly where it's located compared to everything else, it seems to still be inside of it. Or as I mentioned, maybe there are just two of them, extending all the way to 60 astronomical units away from the Sun. And the one explanation here could maybe involve solar radiation pressure that's basically pushing some of the dust slightly farther away. Even that cannot explain the amount being detected right now. Either way, the scientists using the mission are really just hoping to find another large rock to visit, so they can actually confirm all of this once and for all. But then we also have another study that focused on potentially solving one mystery, the mystery of colors. Not a lot of people know this, but Kuiper belt is actually the most colorful place in the entire solar system. Many different objects in the Kuiper belt seem to possess a much wider color range compared to anything else in the solar system. Even some of the images from Pluto were a lot more colorful than we thought. And there's a lot of variability in different colors depending on the object, with none of them actually resembling one another. And so one of these recent papers decided to tackle at least some of them. Here, by using ultra-high vacuum experiments that also involved a lot of radiation, they essentially revealed that, as suspected, it was all because of very complex organic molecules, but specifically the ones containing rings. So for example, things like phenanthrene, phenylene, and acinephthalene, all of which kind of resemble DNA and RNA molecules, tend to end up producing slightly reddish colors. And in this case, this actually explains the colors on Makemake, Orcus, and Salacia, 3 of the dwarf planets in the Kuiper belt. And though obviously other types of rings will produce slightly different colors, the main point in the paper is that it seems to explain the overall mechanism, and it's kind of related to one important concept: galactic cosmic rays. The continuous irradiation by the galactic cosmic rays, especially in these very remote locations where things don't change very much, end up producing some of the more complex chemistry, which then results in some of the most complex organic molecules technically responsible for life on Earth, which by itself implies that there's a really big chance a very similar process involving galactic cosmic rays irradiated a lot of different objects that were headed for Earth and contained a lot of similar ice on their surface, with many of these complex molecules then settling on planet Earth. So yet another potential explanation to how life started on our own planet, or at least how a lot of the individual Lego blocks that build life came here. And then, last but not least, we have more exciting news coming from Makemake and Eris. This is Makemake, and this is a simulation of what a slightly larger Eris might look like. We've actually discussed Eris not so long ago, because it's one of the most important dwarf planets after Pluto, and technically cost Pluto its planetary status. But in essence, this relatively large object, with a radius of just over 1100 kilometers, but a distance from the Sun of 68 astronomical units, has always been assumed to contain some of the most pristine material in the solar system, basically representing a kind of an ancient chunk of really old material that never became any planet or anything else, and orbited the solar system at a very faraway distance for billions of years. And of course, something very similar was expected of Makemake as well. This one is a bit smaller, only 715 kilometers in radius, and is also slightly closer, 46 astronomical units away. And in general, previous observations have always discovered that they do seem to contain a lot of methane ice, which very likely froze on the surface billions of years ago and potentially remained more or less unchanged. But the thing is, something very similar was always assumed about Pluto as well. Yet then we came to visit it, and it turned out to be just a little bit more active. As a matter of fact, it wasn't just active, it was very active. It even contained atmosphere that you can see right there. Although technically this is exosphere because it's not really that dense. And so because of these revelations, a lot of scientists started to make assumptions that, okay, maybe other objects are also kind of active. But for Pluto, it made sense. It actually has 5 moons and one of them is really massive, so they do provide a lot of tidal effects, which do provide a lot of energy inside. But what about those other objects? Well, they were both recently observed by the iconic James Webb. And as always, we have some really exciting discoveries. Here, because James Webb is able to see not just elements and not just compounds but even isotopes, it was able to detect ratios of various isotopes including carbon and hydrogen. And specifically ratios of deuterium to normal hydrogen, as well as carbon-13 to carbon-12. But then also see nitrogen as well. And here, both of the isotopic ratios suggested one thing. The methane here was not old at all. It was actually being resurfaced from within. And the surface itself also appeared to be very young. So yeah, pretty much exactly like on Pluto, which basically presents us with maybe one of 3 explanations, all involving a lot of geochemical processes inside these objects. Either some kind of a solid-state convection, where a lot of material sloshes around, eventually producing cryovolcanoes, or there might be an ocean underneath. And not just any ocean, liquid, potentially hot water ocean. Something that still seems to exist because some of these ratios can only be produced if the resurfacing was very recent. And that's a pretty big discovery for one important reason. They all might be very similar to Enceladus. I guess we should maybe even start calling them Enceladus-likes. And as we've discussed in many previous videos, right now Enceladus is one of the top priorities for maybe one day discovering extraterrestrial life. The oceans here seem to contain everything you would require to maybe produce life, and so if it exists anywhere, it would most likely exist here, somewhere in the oceans. Similarly, Makemake and Eris seem to possess something very similar, thus suggesting we could even have, maybe, life on the outskirts of the solar system, as far away as 68 astronomical units away from the Sun. And so yeah, NASA, or I guess someone else, can we have a spacecraft going there and finding it somehow? Thanks. And though these are obviously preliminary discoveries, at the moment there is really no other explanation for what the scientists discovered in terms of isotopes. And so the chance for these objects to be geologically active and very similar to Europa and Enceladus is extremely high. Which I guess raises the next question. What do you call life coming from Makemake? Makemakean? Makemakes? Yeah, that's a deep question, huh? Anyway, I'm sure we'll learn more in the next few months, but at least for now these are some really cool discoveries from the region we usually do not hear much about. So James Webb Space Telescope might have just solved another important mystery of the universe, the mystery we refer to as Reionization, the unusual period that lasted for approximately 1 billion years, during which time the universe transformed quite dramatically. And intriguingly, this was one of the primary missions for the James Webb, because for many years the researchers could not figure out why the universe transformed early on. And so, hello wonderful person, this is Anton. Let's discuss reionization, discuss the solution to this mystery, and possibly find the conclusion to this scientific saga. And let's find out exactly what was described in a recent paper, and basically what all of this means. But let's start with a bit of a cosmological history. And let's start with this NASA picture showing us the evolution of the universe. Now today we're actually only concerned with the first billion years, specifically the period known as the Dark Ages and the transformation period that followed afterwards. And during that first billion years, the gas in the universe experienced at least 2 different stages of transformation, or 2 different stages of phase transition. The first one happened approximately 380,000 years after the Big Bang. This was a period known as recombination, when basically superhot plasma suddenly turned into gas because the universe was expanding and was cooling down. And this process resulted in the famous CMB, Cosmic Microwave Background, literally the oldest light in the universe, because at this point all of the super thick plasma now turned into hydrogen gas and allowed some of the first light to travel through. Before that, the universe was basically opaque and the light could not travel far. But also at this point, we reach the period known as the Dark Ages. It's called that because, first of all, there are no stars yet, but second of all, because a lot of gas that's present is neutral hydrogen. And by its nature, neutral hydrogen only allows some of the low energy photons to go through, but any light that's able to ionize gas is actually going to be absorbed, thus becoming invisible. And so, for example, some of the first stars that started to produce ultraviolet light, and actually mostly UV light, not so much of anything else, would most likely have all of their light completely absorbed by neutral hydrogen, thus appearing invisible from a distance. But as this neutral hydrogen was absorbing all of this light, it was becoming ionized, which would then allow light to pass through much easier. And so this period of Dark Ages lasted between 150 million years to 1 billion years after the Big Bang, with this simulation sort of showing us what possibly happened. So basically we had these tiny bubbles of reionization forming everywhere in the universe, and eventually spreading more and more, eventually becoming larger and larger, at some point joining in, which then led to the reionization of the entire universe, roughly around 1 billion years after the Big Bang. And the reason we know it's 1 billion years is because of the observations from various quasars. If we look at quasars at a redshift of 6 or more, they usually have certain frequencies missing from their spectrum. Or basically they'll have certain higher frequencies that seem to have been absorbed by neutral hydrogen. But if those quasars are seen much closer to us at a redshift of less than 6, they usually show us all of their wavelengths, suggesting that neutral hydrogen was already gone. And since to ionize hydrogen, we actually need very specific energy, requiring ultraviolet light or something even more energetic such as X-rays or gamma rays, whatever caused the universe to change so much must have been really powerful. But that's where the mystery started. Cosmologists were not certain what exactly was responsible for most of these effects. What exactly caused the Dark Ages to end, and what reionized everything. But there were always at least three main candidates. The first obvious candidate was population 3 stars. Ridiculously powerful but possibly very short-lived first stars in the universe that were made out of only hydrogen and helium, could have also contained hundreds if not thousands of solar masses in mass, and very likely produced a tremendous amount of UV light. They've never actually been seen yet, but their existence is implied based on the observations of various supernova remnants that then resulted in the formation of second-generation stars. Actually, one of the main missions for James Webb Space Telescope is to finally find these stars somewhere, but so far nothing. And so because these stars produce so much UV light, they were always the primary candidate. But most scientists do not think that it was only population 3 stars. They were very likely the first to start ionizing everything, and possibly started the process of reionization, but because generally they would only exist for maximum a few million years, it's extremely unlikely that all of the reionization was done by these types of stars. And so today it's believed that they must have started the reionization for the first few millions of years, but something else took over afterwards, and actually something entirely different very likely caused the entire universe to change dramatically. In other words, to create these bigger bubbles that would then join in and would spread across the entire universe, something else had to be responsible. Now, some researchers believe that maybe it was really massive, really powerful early galaxies. But the thing is, even though we see some of them, the numbers are just not there. There are not enough of them in the early universe to explain anything. However, we do see quite a lot of quasars. Actually, over 1 million have already been discovered in various locations in the universe. And quasars are essentially very, very bright galaxies powered entirely by a really massive central black hole. And because they're generally extremely efficient at producing all sorts of powerful light, with many of them existing before reionization, some scientists believe that maybe it was quasars after all. But based on recent observations by various telescopes, and specifically James Webb observations, it was discovered that the numbers were just not high enough. The researchers were hoping to find a lot of massive black holes in the early universe, but as you might have learned from one of the recent videos, they've actually discovered almost the opposite. The number of quasars and the number of active galaxies does not seem to be as high, which suggests that despite their power, quasars also very likely only contributed a little bit to the total reionization, but were definitely not the main culprits. So if not quasars and not population 3 stars, then what could it be? And the answer that was recently discovered might be just a little bit surprising. It seems to be galaxies, but actually galaxies that we generally do not have around us. Here we're talking about a very specific type of dwarf galaxies that seem to be extremely rare nowadays, but potentially were extremely common billions of years ago. And these types of dwarf galaxies were actually only discovered not so long ago. For example, one of the previous videos in the description talks about these mysterious green P galaxies, or these very compact green galaxies discovered by citizen scientists in the mid-2000s. And it did take a while to explain what's going on here. In essence, these are really compact galaxies producing a lot of stars, but also producing an enormous amount of ultraviolet radiation. They're often tens if not hundreds of times brighter in the UV light than anything else. But much closer to us, there are at least 2 of these galaxies that possess very similar properties as well. The one whose name you see right here, approximately 650 million light years away from us, a galaxy that's practically invisible in optical light but lights up dramatically in the ultraviolet. Here's actually a colorized picture of this, basically showing us what it kind of looks like. And the galaxy known as Haro 11, that's only about 300 million light years away from us, but is also extremely bright in the UV light, basically representing one of the brightest UV objects in this part of the universe. And though finding these types of galaxies close to us is kind of rare, they've always been theorized to exist at faraway distances. And they're actually known as LCEs, Lyman Continuum Emitting Galaxies, responsible for producing super powerful emissions. Or in other words, galaxies that emit a lot of ionizing light, mostly a lot of UV light, but also a lot of X-rays and a lot of other frequencies that tend to ionize gas around them. Now, because we've only seen a few of these galaxies out there, and because their numbers were relatively low compared to anything else, nobody expected these galaxies to be responsible for most of the ionization. But in a recent study using observations from the James Webb, and looking at the famous galactic cluster known as Abell 2744, the researchers found a kind of a chunk of very powerful LCE galaxies, specifically 8 of them, that were actually really faint in optical light, but super bright in the UV, producing a ridiculous amount of ionizing radiation, several times higher than anyone expected. And though each of these galaxies was at least 100 times less massive than the Milky Way, overall they seem to produce several times more ionizing radiation than any of the galaxies nearby. And because so many were found in such a small volume of space, it kind of implied that these types of galaxies were potentially all over the place. We've just never really seen them before, because none of the telescopes were powerful enough to see that far, and because even in this case, it was actually due to gravitational lensing that we're able to detect these tiny galaxies. So for example, in this image, you can even see the outline of the gravitational lens, which magnified the light from these galaxies so much that they finally became visible. And based on the ionizing photons coming from these galaxies, researchers discovered that they most likely produced enough ionizing photons to completely reionize the entire universe. In other words, if enough of these galaxies were present everywhere, they very likely were responsible for all of these microbubbles that eventually joined in, reionizing the whole universe. And because these galaxies were much smaller, they would produce smaller bubbles, reionizing the universe in a much more homogeneous way instead of large chunks. And that's of course exactly what's been observed by many scientists for many years. Reionization seems to be more or less homogeneous, and very likely happened as a result of much smaller bubbles. In other words, the discovery of these 8 really distant dwarf galaxies, combined with the discovery of very similar galaxies close to us, and the discovery of these green peas, to some extent, very likely provides a definitive answer for the problem of reionization. Even though it possibly was started by population 3 stars, it was mostly done by these types of galaxies that produced ridiculously powerful ionizing radiation, much more powerful than anything around us today. As a matter of fact, the only reason these galaxies are even green is because the ionizing radiation inside is so powerful that it causes ionization of oxygen produced by various supernovae, which then starts to glow green, turning the entire galaxy green. And this was probably very common in the first billion years. But with time, as galaxies evolved and as they combined into larger objects, and of course as the star formation settled down, these types of galaxies became extremely rare, and the galaxies we see around us, such as the Milky Way, became much more common. And so once again, the James Webb Space Telescope was able to help us understand how objects we're not familiar with very likely reshape the universe, just because of their sheer numbers. They were most likely everywhere. But this is of course just the first observation, and more additional confirmations will be needed to make this a fact. And so we do have a few more observations coming up, specifically of a galactic cluster known as Abell S1063, and the observations of the program known as GLIMPSE. And so if those observations also discover similar objects at relatively similar distances, the conclusion is going to be pretty obvious. Reionization was caused by dwarf galaxies, very similar to objects we discovered in the last few years, such as for example those green peas. One mystery down, a few more to go. Hello InfoPerson, this is Anton, and today we're going to discuss yet another unusual discovery from the James Webb Space Telescope. And yeah, once again it's galaxies. Galaxies that nobody expected, and galaxies that right now don't really make a lot of sense. But the question is, do these galaxies break any modern theories, and is there anything we're discovering that shouldn't really make sense? So let's discuss this in a little bit more detail, focusing on this new study by Mengyuan Xiao and his team that discovered unusual ultramassive galaxies in the first billion years, the galaxies that have now been nicknamed red monsters. But I guess before we talk about this discovery, let's briefly take a look at some of the recent discoveries from the last few months. Although here I just wanted to focus on some of the strangest discoveries. For example, recently we've discussed this galaxy that was only formed about 200 million years right after the Big Bang that seems to contain unusual brightness, indicating a frenzy of star formation. And because many stars here have been calculated to be at least 90 million years old, it means that all of this has been going on for at least some time. There's actually even signs of things like oxygen that basically suggest several supernovae have already happened, and a lot of dust and a lot of different particles have already mixed in, producing second-generation stars. But once again, this is approximately 290 million years right after the Big Bang, something that was previously thought to be maybe impossible. And since this galaxy also contains a really large halo of very young, very powerful stars that have been actively reshaping this galaxy for at least 90 million years, this was one of the first signs that essentially star formation and galaxy formation might have been extremely different from how we always imagined it to be. And specifically different from various simulations such as the famous Illustris project that showed us galactic formation and star formation as a much slower and a much more methodic process, essentially suggesting that galaxies form gradually and usually inside really large dark matter halos that slowly capture all kinds of gas and eventually forms gravitational instabilities that turn approximately 20% of this gas into various stars and eventually galaxies. This is basically the process you're watching behind me. And so these observations from the James Webb basically put a big question mark on this entire process, with a lot of findings from 2023 and 2024 challenging these previous assumptions. Because it looks like many galaxies actually form stars much more vigorously, and a lot of really massive galaxies in the early universe were potentially very efficient at building stars and growing extremely fast very rapidly. We've actually discussed some of these previous discoveries when we talked about little red dots and the discovery of unusually massive black holes, along with the galaxy known as JWST, the videos about which you can find in the description. And so in essence, in 2023 and early 2024, James Webb Space Telescope started to provide us with a lot of different evidence for these unusually massive, dust-obscured galaxies that were actually hiding huge amounts of star formation and really massive black holes. But one of the main questions that was basically asked here is, okay, so does this actually break some of the theories and some of the assumptions, especially the assumptions coming from the famous lambda CDM model? The model that explains the universe using the dark matter, dark energy, expansion of the universe, and the formation of galaxies using these dark matter principles. In other words, should we actually start rewriting some of the physics and potentially recalculate certain things? And that's basically what this recent study decided to focus on. They essentially tried to reveal unexpected discoveries using these unusual galaxies, mostly present in the first billion years of the universe, in order to see if something is up or if it's still okay, and we're just basically seeing something unusual, but not something that breaks physics. And naturally, for all of these studies, James Webb was absolutely perfect. It helped the researchers reveal a lot of hidden details in many of these observations, even though technically these galaxies have been previously visible to us, even using the Hubble Space Telescope. And here the focus was on 36 massive dust-obscured galaxies with redshifts between 5 and 9. And specifically focusing on the James Webb Fresco program, the link about the survey is also in the description, that mostly uses near-infrared observations and the observations using spectrograph in order to measure extremely accurate distances and also stellar masses of various galaxies. With one of the first discoveries being that, well, looks like the star formation in many of these early galaxies was extremely efficient, much faster and much more vigorous than previously assumed and previously simulated. And that, of course, does actually challenge some of the galactic models. But the main focus was on 36 galaxies, where previously researchers only actually had ultraviolet data, and their actual distances were not yet confirmed. And specifically because with a lot of these galaxies, some studies and of course some videos on YouTube basically claim that many of these discoveries kind of break the modern physical models, including lambda CDM. And especially because so many of them have been discovered at much farther distances than we ever thought possible. But one of the first discoveries from this study is that there does not seem to be any tension with the models we have. Or basically these observations are kind of in line with what's really expected. And remember, this is based on some of the most accurate, most extreme observations we have to date. Out of all of these 36 galaxies, even though they're a little bit unusual, they don't really break anything. And to make the point even stronger here, researchers focus on 3 main galaxies, the 3 giants. 3 ultra-massive galaxies, actually even more massive than the Milky Way, that seem to be forming stars super vigorously, at least twice as much as expected. And here the surprise is that they seem to be just really efficient at forming stars. Approximately 50% of all of the mass seems to be converted into stars instead of being thrown away into the outer galaxy. And it's really this efficiency that's actually kind of surprising. Surprising compared to a lot of similar galaxies at similar distances, or galaxies much closer to us at much later times. So basically these 3 giants are so giant and so bright only because they are very efficient at converting mass into pure energy. At least twice as efficient, but possibly even more. And prior to this, all of the other galaxies usually displayed relatively similar efficiency and were not nearly as efficient. These galaxies really stand out. First of all, they do contain a huge amount of dust, which actually makes them very red in appearance. They're actually some of those unusual little red dots we mentioned previously, but because they're also much brighter, they're now referred to as the red monsters. Monsters that are even technically visible in the optical light as well. But the main focus here was to try to calculate the most precise distance and the most accurate stellar mass measurements, essentially highlighting how extremely accurate some of the observations from the James Webb really are. But once again, this is a really important side note here, none of these observations conflict with modern predictions or modern theories when it comes to the standard cosmological model. The only thing that seems to be in conflict here is the idea behind galactic formation and the efficiency of star formation in a lot of these early galaxies. And so because here we seem to be finding way too many of these really bright, really massive, really powerful galaxies, that's of course the new question. Why? There seem to be some unique processes at work here, and they seem to allow these galaxies to form stars super quickly, but exactly what's responsible for this is currently unknown. It's just a little bit more clear now that early universe was very efficient and produced a lot of stars and many different massive black holes. Something that older predictions could not anticipate, and something the simulations could not show us either. And interestingly, these unusual massive galaxies also seem to actually account for close to 20% of all star formation in the first billion years of the universe. So essentially, a lot of star formation was usually in these very bright, very massive, very concentrated galaxies that became so bright and so powerful that we can actually still see them today. But once again, why? So one of the potential explanations here is that maybe there is some kind of a supernova feedback that we still don't understand that basically causes a lot of star formation in many of these early, really dense galaxies, because many different supernovae start to go off one after another, which basically causes some kind of a chain reaction, forcing new stars to form quickly, go supernova again, and repeat the process over and over. Now this is just an assumption for now, and this is based on some of the interpretations from this study. We obviously have no evidence. But the other potential explanation is that maybe these central black holes play some kind of a role in this as well. Specifically, maybe these active nuclei, or these active black holes, contribute to star formation in some kind of an unusual way. So basically, if we find a galaxy with a really massive, really powerful black hole, especially in the early universe, it seems to somehow encourage the star formation as opposed to extinguishing stars, which is usually what we see in a lot of different black hole systems in the universe today. Likewise, maybe there's something else going on here, such as contributions from mysterious dark matter, dark energy, or something else entirely. Maybe it's all about very powerful magnetic fields, which many of these galaxies very likely possessed. And so right now there is really no clear picture and no clear explanation, just a lot of evidence that many different galaxies early on were super efficient, and efficient at both producing stars and producing massive black holes. But when it comes to breaking physical models, and especially the dark matter, dark energy, lambda CDM model, right now we seem to be kind of fine. These new observations still fit the model, and the researchers once again find no tension with anything. So yeah, the Big Bang still stands, dark matter and dark energy still seems to exist, and yeah, you probably have to go to work or to school tomorrow. Hello info person, this is Anton, and today we're going to discuss a relatively intriguing discovery that we've actually never seen before. A discovery of what you see right here. And though this might not look like much, the scientists who discovered this are now referring to this as Einstein's Zigzag. A kind of a variation from the typical Einstein ring or Einstein cross that have been previously discovered by many different telescopes in the last few decades. But unlike previous discoveries, like the Einstein ring you see right here, this time this one is really special and somewhat unusual. And so let's discuss this in a little bit more detail, but I guess let's start with the basics of how all of this works. All of this is of course a type of a gravitational lens, or essentially the bending of light as a result of some kind of a massive object between the observer and the source of the light. The concept originally theorized and proposed by Einstein in the early 1900s, and then for the first time ever confirmed by the famous Sir Arthur Eddington. This was the famous Eddington experiment that on 29th of May 1919 was able to prove Einstein correct by observing a slight deviations of the travel of the starlight during the totality and during the solar eclipse, which basically resulted in this headline in the New York Times, and also made Einstein pretty much famous overnight. But today these gravitational lenses are also important for a slightly different reason. Because the light in this case travels from the same object, but it very often reaches planet Earth at different times, since it actually travels a slightly different distance, this technically allows us to see the same object at different times and with a different redshift, which for cosmology is super important. It essentially allows researchers to calculate how fast the universe is expanding and also allows us to test various theories in regards to redshift and the mysterious dark energy. And so these Einstein rings, or really anything to do with gravitational lensing, is basically like a treasure for astronomers and cosmologists. And so most of the cosmological secrets will most likely one day be solved by observing a lot of these lenses. And turns out that one telescope has actually been fundamental in discovering so many more. That telescope is the James Webb. In the last 2 years it actually discovered some really incredible lenses, and some we've never seen before. As a matter of fact, just last year it discovered JWST ER1, the most distant gravitational lensed object we've ever seen, roughly around 21 billion light-years away from our planet and previously completely invisible. But naturally, even Hubble telescope was pretty good at discovering these as well. Here are just some of the discoveries from the last few years. And even more recently, Hubble, completely by accident, discovered one of the most important gravitational lenses in the last few decades. It's the lens that you see right here. It's now referred to as the carousel lens because it basically contains a bunch of different galaxies whose light is coming from different distances, anywhere from 7 to 12 billion light-years away from the planet. And specifically, there are at least 7 galaxies that all appear to be relatively normal, relatively quiet, but still visible because of this lensing, even though they're super far away. So basically in this lens, we're seeing various objects billions of light-years apart, with at least one galaxy, Galaxy 4, forming an almost perfect Einstein cross, and the galaxy known as 7, discovered to be some kind of an ancient red galaxy that for some reason seems to be completely quiet and is not forming new stars. Now we still don't really know much about this and it hasn't been studied in more detail, but this was an intriguing discovery from Hubble. But then just a few months later, James Webb basically said, yeah, hold my beer. Here's something even more impressive. This is now referred to as J1721 plus 8842, or unofficially Einstein's Zigzag, based on a discovery from back in 2018. Here, this was a somewhat unusual discovery of 4 bright points billions of light-years away from us that also appeared to have 2 additional points that were much dimmer. And well, initially this was assumed to be some kind of an Einstein cross. Here's a typical example from back in 1985. And this is of course a very similar principle. We have a very bright, very distant object whose light creates 4 individual points as it's bent by some kind of a mass between us and this object. But in 2021, an additional study, and here we're talking about this study by Lemon and his team, suggested that this could be some kind of a binary object or even a binary quasar with essentially 2 supermassive black holes very close to each other, possibly even orbiting, that produce these 6 points. And on top of this, there was also a discovery of a somewhat faint red Einstein ring that you can see right here. And this is when this object became super interesting, but it looks like that study might have been actually incorrect. because once researchers took a look at these 2 points once again, the ones that were not as bright, they realized that this is actually all the same object. And so instead of a binary quasar that was duplicated 3 times, this seemed to be a single quasar that basically made 6 copies. And all of this was confirmed through a very thorough reanalysis, including the analysis of spectrum showing what these galaxies contain, which confirmed that this was indeed the same object. But the object that was basically bent in a very bizarre way, in a way we've never seen before, with the additional discovery basically suggesting that these newly discovered bright spots have actually been lensed twice around a second massive object, which then also formed this unusual Einstein ring. And so in essence, if we were to try to imagine what all of this looks like, we have the first deflector at a redshift of 1.88 and the second deflector that's much closer, which essentially causes the light here to kind of go through an unusual zigzag, forming these 6 points and a somewhat unfinished Einstein ring. With all of this basically confirmed after approximately 2 years of observations, when the researchers realized that there's basically just a slight delay in time between all of these 6 images. So it's essentially kind of like looking at separate frames of the same object, but those faint points represented the farthest distance traveled, implying that this light is doubly lensed and represents highly redshifted photons, which is basically a goldmine for cosmologists. Because this is essentially an extremely rare and very unusual object that first of all can help us answer questions about dark matter, at least in one of these lenses, and that's because by comparing how light bends here, scientists can actually work out how much mass and dark matter is present in each of these lenses, but much more importantly, the time delay between these images allows scientists to figure out how fast the universe is expanding. Here, by calculating individual differences in arrival, and by comparing this with values for the expansion of the universe, it might lead to additional answers in regards to mysteries of dark energy and the bizarre phenomenon known as the Hubble tension. You can learn about these principles in some of the previous videos in the description. And so because in this case the light from this object passes through 2 different points of space that then warps it in very different ways, by comparing this to predicted models, it becomes possible to measure everything about these lenses, working out a lot of cosmological parameters all at once. And so once again, for cosmologists, this is probably one of the most important discoveries in the last few decades, an extremely rare lensing phenomenon that we'll probably be talking more about once there are some additional discoveries. But I guess for me personally, it's actually kind of mind-blowing that something like this even exists. Here, as you can see, the light really travels in some super bizarre ways, distorting the reality from distant universe in ways we cannot even imagine. And so in some sense, a lot of things we see at faraway distances potentially look completely different in real life just because of all of these gravitational lensing effects from enormous amounts of mass present between the light and us, with objects like this reminding us how completely bizarre the universe really is. Hello wonderful person, this is Anton, and today we're going to discuss UFOs. Okay, I got you, not the ones with aliens. In this case, UFOs actually refer to a really intriguing type of a galaxy that was only discovered a few years back. And in this case, UFO stands for Ultra Red Flattened Object, and only discovered by the James Webb Space Telescope. And so essentially, we're going to be discussing yet another unusual mysterious type of a galaxy uncovered by the James Webb. But I guess here, let's start with the actual picture, which kind of explains why they're called UFOs. And so here we have the observations from the Hubble Space Telescope that basically reveal nothing, and the much more recent observations from the James Webb that suddenly reveal an unusual red flattened object that also kind of resembles a saucer, which is why almost right away many astronomers started to refer to them as UFOs. And this wasn't just like 1 or 2 galaxies, a huge amount of them was actually discovered all over the place, all completely invisible to the Hubble Space Telescope, but then suddenly appearing as these really bright red objects to the James Webb. Here's a bunch more examples from just the last few months, basically showing you the same phenomenon over and over. And naturally, this was a huge surprise. Not only was it difficult to explain what's really happening here, it also created a bit of a problem for the previous assumptions in regards to the number of galaxies in certain regions of the universe. Because here this meant that even in the much older universe, even though we actually expected nothing to exist there, there was a bunch of invisible galaxies that were previously completely ignored. And in this case, they all seem to be kind of similar. All of them were somewhat large, unusually spatially extended or basically stretched, but all extremely red and predominantly visible in the infrared, almost completely invisible to a regular telescope. And even for the scientists using the James Webb, this was a huge surprise. Because here the assumption was that since James Webb is able to see much farther away, we're only going to be discovering new galaxies at these super extreme distances, which naturally it's also discovered. But in this case, nobody thought we would find galaxies much closer to us when the universe was already 3.5 billion years old. And so here we had these massive red galaxies suddenly appearing out of nowhere. And like I mentioned, a lot of them, way more than anyone expected. And here's how they compare to a typical galaxy visible at a similar distance. And the first discovery was reported in this study from the August of 2022. And so here Erica Nelson and her team basically discovered all of these galaxies completely by accident. But back then they were just referred to as HST dark galaxies, or essentially galaxies invisible to the Hubble Space Telescope. But unofficially, everyone called them UFOs. And in most cases they were not that far away. The redshift here was about 2 to 6, so basically when the universe was anywhere from 1 billion to approximately 4 billion years old, with the first analysis revealing that basically they were just galaxies covered by a huge amount of dust, with this dust blocking most of the light and only allowing infrared light through. So essentially here we were just looking at very red, very dark galaxies. Or I guess more like huge dust clouds resembling galactic shapes. But to the infrared observations from the James Webb Space Telescope, these galaxies were extremely bright. They basically stood out right away and were visible in practically every single image, with all of them revealing very similar features. All of them were kind of similar in mass to the Milky Way galaxy, so already quite massive and quite developed, but all undergoing huge amounts of starburst activity, forming approximately 1,000 times more stars than the Milky Way, potentially representing some of the most starbursty galaxies during this time, basically producing most stars during the first few billions of years, but also, for some reason, covered in dust. And like a lot of dust. Up to 100 times more than in a galaxy like the Milky Way. And while at first it was assumed that maybe these are actually progenitors to some of the most massive elliptical galaxies, such as the famous M87. Even today, we still have no idea how a lot of these galaxies formed, and why many of them are so ridiculously massive, and are also shaped in such a weird way. But this was just an assumption based on the amount of stars these galaxies were forming. But now, after 2.5 years, we have an additional study from a similar team by Justice Gibson and Erica Nelson that basically analyzed these galaxies even more, making some additional discoveries. And so here, first of all, by using what's known as the JADES collaboration, which stands for JWST Advanced Deep Extragalactic Survey, here once again they discovered quite a lot of these invisible objects. But out of 112 of them, 56, or basically half, were classified as UFOs. And in every single case, they all possessed extremely similar properties. First of all, obviously more dust than any other galaxy, basically so much dust that all of the light here is covered entirely, with only infrared getting through. Here they basically compare it to a kind of a sandstorm inside the galaxy, making it practically invisible to a typical telescope. But also a lot of them actually seem to be very similar in shape to the Milky Way galaxy. Many of them had disks, they also had central bulges, and many of them were quite developed, except that they were basically once again invisible. With the only real mystery here being that, for some reason, they all contained a huge amount of dust. But where exactly this dust came from, or what became of these galaxies in the last few billions of years, that's actually the mystery. Because in the modern universe, in the last few billions of years, we see nothing like this. It's as if all of these UFOs only appeared for a few billion years and then transformed into something entirely different. So basically, one of the last UFOs potentially existed approximately 10 billion years ago. And here once again the existence of these galaxies was basically confirmed by looking at similar images from the Hubble Space Telescope and discovering nothing in the same location. Most galaxies were invisible, and only some showed just a little bit of red dust, which is basically what they would look like to us if we were to somehow see them in the night skies. it would just look like a very dark red cloud. But in this case, researchers also used computer simulations and modeling to try to understand what's inside these galaxies and what they look like in real life. And though most galaxies can be basically any shape, including irregular shapes, spherical or elliptical, for some reason UFO galaxies basically resembled the Milky Way. They were structured disks and were more or less flat. And because they all resemble typical spiral galaxies, once again, it's kind of unclear where all of this dust is from. Because if these were elliptical galaxies, there might have been some kind of an explanation, and even some kind of an evolutionary process that would eventually lead these galaxies to become galaxies like M87, really massive elliptical galaxies containing lots of stars and lots of dust. Yet that's not really the case. Here we have these very typical disk galaxies that even contain a central bulge that also resemble a typical starburst galaxy, such as for example NGC 5248 that you see right here, except that this galaxy we see really well, and it does not have the dust. Yet UFOs are unique in that they do look very similar, but they're just super dusty. And in comparison, one of the dustiest nearby galaxies is what's known as the Sculptor galaxy. It's about 13 million light years away from us, and it does contain a lot of dust lanes that actually hide many different stars and different clusters from typical telescopes, and that only become visible to specialized telescopes like the James Webb. In contrast, there is also this. This is a discovery from 2023, and once again by the James Webb, and is one of the earlier galaxies that existed 13 billion years ago. And here this is not a UFO, but it's an extremely active starburst galaxy, currently known as Aztec 71, that's also extremely rich in dust, and basically implies that these galaxies were just extremely common in the early universe. Which means that these dusty galaxies were very likely just a common occurrence during the first 3 billion years. But once again, the mystery here is, what exactly did they become? Did they actually turn into one of the spiral galaxies, eventually losing all of the dust? Or something more exotic? And I guess more specifically, where did all of this dust eventually go? Because here we're talking about galaxies containing hundreds of times more dust than a typical galaxy like the Milky Way. Getting rid of this dust and turning it into something is definitely not an easy process. And so the only solution here is to find some kind of an intermediate state, possibly 5 to 6 billion years ago, which can possibly show us the process that eventually turned these dusty galaxies into something more familiar. Okay, let's start this video with a picture. Right here, you're looking at another galaxy discovered by the James Webb that sort of, violates a lot of current physics when it comes to galactic formation, or at least violates modern understanding of how galaxies might have formed early on. In other words, James Webb just discovered another impossible galaxy. But I think at this point, it's not even surprising anymore. So far, James Webb had made so many incredible discoveries, and quite a lot of them seem to be rewriting textbooks as we speak. And so, hello wonderful person, this is Anton, and today we're going to discuss even more discoveries from the James Webb that once again maybe don't actually make sense, at least for now. But we'll actually discuss a couple of discoveries, with at least one of them kind of making sense, and possibly showing us how our own galaxy, the Milky Way, developed billions of years ago. But before we start, let's go a few months back to November of 2023. This was just a few months ago from when I'm making this video, but back then we discussed a galaxy known as Ceres 2112, a galaxy whose light took approximately 11.7 billion years to reach us, and a galaxy that, though appeared to be relatively normal, turned out to be really surprising because it contained signs of a bar in the middle. In other words, this was a spiral galaxy with a central bar right in the middle. And though it might not be surprising today, for such an old galaxy, this was actually a really surprising discovery. This implied that bars might have existed billions of years before we thought they were possible, with previous assumptions suggesting that bars should not have existed for at least 5 more billion years. This discovery from just a few months ago definitely raised a few eyebrows. Here it was very difficult to explain how such a structure could form so early, and how exactly this galaxy was formed to begin with. But it only took a few more months to discover what we have now, something that's even more mysterious. A galaxy referred to as JWST 7329, a galaxy at a relatively similar distance to the previous one. The light here traveled for about 11.5 billion years. But what's intriguing about this discovery is actually how advanced and how extremely massive this galaxy is compared to anything else we've seen. First of all, it seems to contain at least 4 times as many stars as our own galaxy, the Milky Way. And in this case, all of the stars seem to be approximately 1.5 billion years old, suggesting that the galaxy is approximately 13 billion years old. Now here it doesn't actually violate any laws yet, and it doesn't break any physics. As a matter of fact, it does suggest that the Big Bang still stands, but the problem here is the formation. How did it form so quickly and grow so big in such a short time? For example, according to modern models involving dark matter and cosmic web, all of this should have taken a much longer time, since the universe very likely started much smoother and eventually became more condensed, with dark matter eventually forming larger and larger patches and forming larger and larger clusters. All of this would have taken billions of years to form in order to form clumps large enough to produce massive galaxies like the Milky Way. Actually, the main problem here is hydrogen. It would take at least a few billion years for all of this hydrogen to clump into a large enough environment to start forming these huge galaxies like the ones we see today. Or I guess that's the old model. That's the model that we always believed based on various computer simulations and based on the cosmological interpretations before James Webb became operational. But this galaxy kind of breaks all of this. It really should not exist with the properties we're observing. Galaxies around this time should really be more disordered, more clumpy, extremely active, producing a lot of stars and a lot of light, and generally lack complexity. They should be basically very chaotic. Yet here we have this extremely orderly galaxy, practically resembling the Milky Way, containing a huge amount of stars already, but even more intriguingly, actually quiescent. It doesn't seem to be active, and it does not seem to produce a lot of light. In other words, this is technically a dead galaxy. A galaxy that stopped active star formation, but during the period where most galaxies were producing a lot of stars. This is actually during the cosmic noon. And so the question here is, of course, how such a large galaxy, such a complex galaxy, and more importantly, a galaxy that stopped producing stars, could form so quickly, so early on. At the moment, this really makes no sense in terms of modern theories. And there is really no explanation for what stopped its formation and what exactly stopped the star development. Why is this galaxy now dead and is no longer producing stars? Normally, in most galaxies, this is possibly due to some kind of a black hole activity or possibly tidal stripping from a nearby galaxy. But here the black hole seems to be relatively mild, and we don't really see a lot of partners nearby, with galaxies visible in the image actually being much closer to us. Which means that right now this galaxy is completely unexplainable using modern cosmological models. But it also implies that our current models of dark matter and the cosmic web might be incomplete or maybe even completely incorrect. Because it's quite clear that this galaxy was able to develop really quickly and was able to get enough gas from somewhere at least 5 billion years before we thought it was possible. And so basically somehow it was able to grow in just 1.5 billion years, developing extremely quickly and forming its current complex shape in just a fraction of time. And though it is possible that maybe it was just in some kind of a super condensated, super large chunk of dark matter that contained a lot of gas in the middle, making this some kind of a rare exception, not really a rule, since there are no other clues and no other evidence, at the moment nobody knows. But it definitely changes our understanding of how we always believed dark matter helped the universe evolve. It basically suggests that many of these computer simulations, such as the one you see right here, known as the Illustris project, might be just a little bit too simple and seem to lack something in them in order to explain these very early galaxies that seem to be extremely complex much sooner than anything else. Now right now we basically only discovered two, one with a galactic bar and one that's extremely massive and contains a lot of stars. But these two galaxies are enough to start asking a lot of questions. Questions about the standard model of cosmology, and specifically questions about dark matter, and how various galaxies like the Milky Way formed in the universe so early on. But obviously this is just two objects for now. Hopefully we'll find more, but at the moment this is really more of an exception, definitely not the rule, and definitely not something we observe everywhere. As a matter of fact, the additional observation from just a few days ago does actually provide us with a lot of evidence for how various galaxies like the Milky Way might have formed around the same time when we expect them to form. And this is actually observations from even farther away. Here the light took 13 billion years to reach us, because this is at a redshift of 8.3. And what we're seeing in this image are literally tiny pieces of a large galaxy, specifically star clusters, in this case at least 10 separate clusters, that seem to be slowly growing into a large galaxy through the process of merger. And here they actually found several galaxies at this distance that basically contain a kind of a network of really massive star clusters that show us how these early galaxies developed and how they grew in size. But more importantly, all of this kind of meets our expectations based on the modern cosmological ideas. This is kind of what we expect from a Milky Way-like galaxy early on, and how we believe our galaxy grew as well. And so during this early star formation, when it was extremely rich in gas and contained a lot of early stars, this young galaxy potentially combined a lot of clusters, ranging in mass from 200,000 to possibly 600,000 solar masses. It's actually something that you can see right here in the Illustrious simulation as well, and it's basically something that was always predicted but just never observed. And so in this case, we seem to get a lot of supportive evidence for modern cosmological ideas when it comes to galactic development and evolution. And intriguingly, a lot of the stars formed in this case seem to have gone through a kind of a burst of star formation around the same time. This might have happened because of some kind of a galactic interaction or a galactic collision, and was possibly caused by one of the partners you see right here. In this case, the scientists decided to give them somewhat cute names: Firefly Best Friend and Firefly New Best Friend. Basically two other galaxies potentially causing star formation in the main galaxy referred to as the Firefly. And so the central galaxy, known as the Firefly Sparkle, is most likely a progenitor to galaxies very similar to the Milky Way, essentially showing us some of the earliest stages just 600 million years after the Big Bang. And here the researchers were even able to calculate the temperature, suggesting that some of these clusters are really hot: 40,000 Celsius, 72,000 Fahrenheit, with many of these stars being very primitive and extremely poor in metals, basically mostly containing hydrogen and helium. Once again, something that's kind of expected. But I guess the more intriguing question here is, what do we think happened to these clusters later on? Did they remain in the galaxy, or did they change into something else? Well, in this case, it's believed that most of these clusters, because of various tidal interactions, are actually going to eventually fall apart, in essence forming the galactic stellar disk and the halo of the galaxy. And so it's quite unlikely that any of these clusters are going to survive for 13 billion years. But some might, because we know that our galaxy contains a few clusters that are at least 13 billion years old. Either way, a super exciting observation, and unlike previous discovery, a direct confirmation of what we believe about the Milky Way and how early galaxies like the Milky Way potentially formed. Which I guess means that we shouldn't really be throwing away our physics textbooks just yet. Maybe, just maybe, this is actually the correct model, and this right here might be just a very rare exception. So today we're going to go back and talk about a very exciting galaxy that was originally discovered back in 2015. Back then, this was the farthest galaxy known to us, the galaxy GN-Z11. And the Z11 here stands for the redshift. The redshift of this galaxy back then made it the farthest object we've ever seen, existing approximately 13.4 billion years ago, or approximately 400 million years after the Big Bang. And although since then, James Webb Space Telescope discovered something that's even a little bit farther, even today, GN-Z11 is still one of the most exciting and most studied distant galaxies ever. And as you're going to learn in this video, there have been a few really exciting discoveries coming out of this galaxy, taking us a little bit closer to solving a few cosmological mysteries. And so, hello wonderful person, this is Anton. Let's discuss this galaxy once again, talk about some of the more recent discoveries that came out of two separate studies, and of course talk about why some of these discoveries are kind of important. But first, so exactly what is this? Well, based on some of the preliminary discoveries, we know that this galaxy is about 4% the size of the Milky Way and contains about 1% of the mass. So it's actually relatively small, technically a dwarf galaxy. But it's also ridiculously bright. It's forming stars at least 20 times as fast, and it's producing an enormous amount of light, making this an extremely luminous object visible from very far away. How far away? Well, if you consider the expansion of the universe, 32 billion light years away from us. Once again, redshift of almost 11. In comparison, here's what the record holder looks like, the one discovered by the James Webb. This is at a redshift of 13.2, and just a little bit farther away, 33.6 billion light years, and definitely does not look as impressive or as bright. Actually, at least one study we've discussed previously even suggested that maybe, just maybe, this is not a galaxy, but instead some kind of a dark star made out of primordial dark matter. You can learn more about this in one of the videos in the description. But a lot of recent studies actually focused on something a little bit more detailed. They used observations from the James Webb to study spectroscopy, or in essence, how the light changes by passing through various gases inside the galaxy in order to reveal what sort of elements are inside, but also reconstruct the overall structure of gas in a galaxy, potentially discovering certain mysteries. Now, because James Webb is so powerful, it's physically able to see a lot of chunks of gas at really far away distances, and it can even tell us what sort of gas this is. And one of the recent studies discovered that there is a really high concentration of super dense gas somewhere in the center, and specifically a very thick, very dense gas that seems to contain a lot of ionized elements that are very likely created by something extremely powerful, with the first assumption of course being a supermassive black hole. But just seeing gas was not enough, so the researchers behind the recent study decided to find a few more clues. So first of all, in order to ionize elements, something really powerful has to happen in the vicinity. But turns out that these ionized elements were also moving really fast, approximately 800 to 1000 km per second compared to the rest of the galaxy, suggesting that something was spewing them out. The only way to explain this outflow velocity is once again with a massive black hole. Although here what we're observing are the galactic winds, basically all of this gas being thrown out of the galaxy by a very powerful active galactic nucleus or active black hole in the center that's transforming everything inside the galaxy through a lot of vigorous activity right in the middle. And so here, by analyzing the speed of gas, the total mass of gas, and by looking at the density in the center, the researchers discovered a few more details about what it is. A black hole approximately 2 million solar masses in mass that seems to be accreting material 5 times the normal limit, what we refer to as the Eddington limit, which basically means that it's so ridiculously bright that the light produced by the black hole sort of pushes everything out of the system, even counteracting gravity. And because in this case, all of the spectroscopy, or all of the colors, seem to indicate that this is a black hole and nothing else, it actually means that we now officially have the farthest supermassive black hole ever seen. But since it's about 2 million solar masses, or approximately half the mass of the one in the Milky Way galaxy, it is a little bit surprising. I mean, since this galaxy is only 1% the mass of the Milky Way, but contains such a huge black hole, it's not entirely clear how all of this could have formed so quick. Here it's believed that the stars are only about 40 million years old, and so that means that all of this possibly formed really quickly. But James Webb might have actually solved one of these mysteries of ancient black holes in one of the recent studies that you can learn more about in one of the videos in the description. And so anyway, looks like we have the most distant active black hole ever seen. But this wasn't the only discovery coming from the galaxy and coming from that James Webb data. Here it was also able to analyze other gas clouds, specifically various clumps surrounding the galaxy, not really in the center. And intriguingly, what they found was a huge concentration of helium gas. Actually, a huge clump of helium that seems to surround GNZ11. And since there's only helium and hydrogen forming extremely dense clumps, this kind of corresponds to a really intriguing proposition from a few years ago. An idea that a lot of these helium clumps very likely eventually result in population 3 stars. The mysterious primordial first stars in the universe made entirely out of hydrogen and helium and nothing else. And one of the primary missions for the James Webb is to try to find evidence for these stars. Or even better, actually see them somewhere. But so far evidence has been kind of sparse. This though is the best evidence we have. These tiny concentrated pockets of helium, extremely close to a massive galaxy in the first billion years, is actually how the scientists expect population 3 stars formed through the process of direct collapse of all of these clouds into these really massive super hot objects. objects that would be at least 500 solar masses in mass and possibly up to several thousand masses, with all of them burning with extreme heat and very likely just exploding completely once they become unstable. And so these are definitely not like any stars around us and will be something very extreme, extremely huge in size, and producing massive explosions. But because their lifetime is expected to be really short, possibly just a few thousand years, or maybe even shorter, trying to capture that one frame where many of them existed has been so far really difficult. And so basically here, we either find gas before these stars formed, or in some cases find gas that seems to indicate supernova from these stars, something we actually discussed in one of the recent videos about a potential discovery right here in the Milky Way. So yeah, there was a star found here that must have been created from a supernova from one of these stars. But trying to find evidence of the actual stars still existing so far has been very difficult. But since a lot of these very thick clouds of helium potentially existed for millions of years after the Big Bang, chances are there were several periods during which these unusual stars could have formed. And so one day we might actually find one of them, as long as we keep looking. But what's actually exciting about this discovery of these helium clouds is that some of them are once again ionized. And ionized helium, specifically the one that's seen in this case, has always been believed to be a sign of population 3 stars illuminating the clouds around them. And intriguingly, if this is correct and if these are indeed clouds illuminated by these super powerful stars, then these stars must be super bright. The luminosity for a single star here is approximately 20 billion times higher than the Sun. So yeah, let me repeat that again. 20 billion times more luminous than our Sun. And that makes it a ridiculously bright object. And so unless there's another explanation for why these helium clouds are the way they are, right now this seems to be the best evidence we have for the existence of primordial population 3 stars. Although technically there was another study from a few months ago that potentially found signs of these population 3 stars in a different location. This was from a stellar complex known as LAP-1, which is an acronym for Lensed and Pristine. Pristine because it doesn't seem to contain anything except for very basic elements. But interestingly, a lot of these elements are extremely ionized, once again suggesting something super powerful, very likely with a lot of UV light, hiding somewhere in the middle. And so back then in 2023, the researchers believed that this is also the sign of population 3 stars that seem to be present in some kind of a growing galaxy. But the evidence was not as strong as the evidence from GNZ11. Right now, what we're seeing from this distant galaxy is extremely difficult to argue with. There's basically no other explanation for this ionized helium except for very powerful, extremely massive stars somewhere in the center. And stars way too bright to be anything but huge chunks of hydrogen and helium, hundreds of solar masses in mass. But we're probably not going to know more until future studies and until future observations. For now, this is going to remain just a hypothesis, but at least the black hole in this galaxy has now been officially confirmed, basically making this unusual galaxy one of the most exciting objects discovered in the last 10 years. Hello wonderful person, this is Anton, and today we're going to be discussing some of the new discoveries about the unusual poofy planets. Various unusual planets discovered in the last decade that for some unknown reason seem to be extremely low in density. Or to be more exact, seem to actually have relatively small mass but incredibly large size. Sometimes even larger than Jupiter, despite masses being relatively low, comparable to a planet like Neptune or just several masses of planet Earth. And though for the most part their existence is still a little bit mysterious, we're now getting just a little bit closer to cracking the mystery of how they exist and why they're so extremely large. And this is actually based on several new studies, with one of them involving the James Webb Space Telescope that's finally been able to do something we've never been able to do before. But before we discuss the specific details, let's briefly discuss exactly what these planets are and how they differ from one another. Because even though we call all of them poofy planets, there are a lot of individual differences. And here's actually one of the most recent discoveries from just a few days ago. A new planet, WASP-193b, that's about 50% bigger than Jupiter, but by mass seems to be the second lightest such planet ever discovered. In this case classifying as the extreme version of a poofy planet, also referred to as a cotton candy planet. Yeah, these names get really funky. And so the discovery of this planet actually raises more mysteries. Here the assumption is that it's mostly made out of hydrogen and helium and seems to be at the maximum possible size. Or essentially it reaches what's known as the Roche limit, where basically as it gets bigger and bigger, the gas from the outside gets captured by the star and escapes into outer space. Although to be more exact, this is known as the Roche lobe and resembles something like this. So we have this star right here, with the planet reaching its maximum size. And because the mass of this planet was so extremely small, it actually took 4 years to even calculate it. In this case, this is done by using what's known as the radial velocity method, or essentially observing how the planet influences the motion of the star. It basically creates a tiny wobble in the star's orbit, which is usually how we calculate the mass. But in this case, because this particular planet was much lighter than other planets, despite its huge size, it was extremely difficult to see any of this. Nevertheless, the researchers, whose paper you can find in the description, were finally able to confirm that this is one of the most extreme poofy planets or cotton candy planets ever discovered. But it still doesn't tell us why it's like this. Here it's actually only assumed that this is because of light gases. And on top of this, the idea of these poofy planets is also somewhat vague, because here we're actually combining completely different types of planets. For example, here is an illustration of what's known as a superpoof. In essence, a planet that's maybe just a few masses of planet Earth, but usually possesses a size of Neptune or even more. And these are generally much cooler in temperature, possibly 100 to 300 Celsius, and thus potentially represent their own type of a planet. In contrast, these cotton candy planets are usually much larger, bigger than Jupiter, with the overall mass several times larger than what we have here. And so here it's not entirely clear if they all have the same origin, and if their size difference is caused by a different mechanism. For example, some explanations here involved just observational bias. For example, maybe what we're observing is not the actual planetary size, but instead some kind of a gas streaming from the surface of the planet that makes it appear much larger. Or, as suggested by some other studies, maybe what we're observing are actually rings. And in this case, huge rings that seem to engulf the planet, making it appear large from the outside. But in most cases, all of these planets seem to be relatively close to the star and also seem to be relatively hot. And so it was always assumed that it was the heat from the star that inflated their atmosphere somehow. We don't really know how yet, but that's basically what one of the studies we're discussing today tried to tackle. But in some cases, even if you take temperature into consideration, quite a few of these planets are still larger than they should be, with some additional explanations essentially trying to explain this using still unknown chemistry in the upper atmosphere, or maybe the interaction between atmospheric winds and the planet's magnetosphere that creates various electric currents, heating up and expanding the planet. So essentially maybe this is all a result of some kind of a atmospheric ionization, basically making these planets strangely electric, superheated and very expanded. So in essence, at least for now, there does not seem to be one explanation for all of them, but we might finally have an explanation for at least one of these planets. WASP 107b, a planet 200 light-years away from us, discovered back in 2017 that seems to have an unusual misaligned and eccentric orbit that takes approximately 5.7 days. And though the planet is about the same size as Jupiter, it seems to be only about 1/10 of its mass. So once again, this is a superpoof or just a general poofy planet. And back in 2018, this was actually the first time researchers found helium around any exoplanet out there. So we know this planet definitely contains helium. With additional observations in 2023, also discovering water vapor, sulfur dioxide, and even a few silicates inside the clouds. With these early observations establishing this planet as a perfect candidate to study the atmospheres of these very unique, very unusual planets. Which is exactly why James Webb Space Telescope just took another look at this planet, discovering so much more in the process, with these new discoveries visible in this graph. And there are actually a few surprises. First of all, this definitely confirms water vapor, sulfur dioxide, and various silicates. But even though the researchers expected a lot of methane, kind of like what we have on Neptune and Uranus, here they discovered almost none, or to be more exact, about 1,000 times less than expected. And so there was some methane, just very small amounts. And in one of the studies that you can find in the description, researchers explain this as one of the potential explanations to why it's so big. Here they basically suggest that methane very likely transforms into something else as it flows upwards in the atmosphere and very likely interacts with a lot of other chemicals, and also obviously starlight, which causes gases to change, destroying methane in the process, and surprisingly elevating the amounts of carbon dioxide and carbon monoxide, both of which were discovered in these new observations. Surprisingly, unlike expected, this planet also contains way more heavy elements, even more than Uranus and Neptune, potentially suggesting that this planet is actually really hot on the inside. Or basically that it has a relatively hot core, which is also very likely extremely massive. Which is a little bit counterintuitive, as almost the opposite was expected at first. Very small core, a lot of light gases, and thus a large size. Instead, here, the core is assumed to be approximately 11 to 12 masses of planet Earth, and is very likely super hot, potentially representing the main source of heat, with the star in this case only providing a little bit more. And this explains how and why this planet exists and why it's the way it is. Because having a small core with a lot of hydrogen and helium is actually really difficult to explain. A typical planet should not be able to acquire so much gas if it has a relatively small core. But here, by having a large core, this planet was able to accumulate a lot of gas, and by being super hot on the inside, it then basically creates a lot of additional chemistry and a lot of additional circulation inside the atmosphere, which mixes a lot of gases inside and creates a lot of chemistry we still don't really understand. And so it's very likely superheated gas from inside the planet that actively mixes with various layers that seems to first of all destroy methane, which is usually unstable at high temperatures, but second of all expands the atmosphere of this planet, making it poofier than it should be. But despite this core being twice as large as initially assumed, it still does not explain why it's so hot. The star cannot in this case make it so hot, so something else has to be responsible for all of this. And here the answer is in its unusual orbit. As previously mentioned, this planet seems to have a somewhat eccentric orbit, and there's also another planet in the star system that pulls on this planet as well, which essentially results in what we refer to as tidal heating. This is what we usually observe on objects like, for example, Io around Jupiter. And so it's really the tidal heating caused by this unusual orbit that's most likely responsible for the superheated core. And that superheated core is then responsible for inflating the planet. And so here the explanation seems to be somewhat simple. You have an object similar to Neptune with a much larger core containing rock, or basically silicates, but potentially slightly less gas. But this core is superheated by tidal forces from the star and from the additional planets, with all of this heat escaping by causing the upper atmosphere to expand and to start mixing vigorously, initiating a lot of additional chemical reactions, but also puffs up this planet so much that it becomes almost Jupiter-like in size. Or at least that's the initial explanation from two separate papers that you can find in the description below. But even more importantly, here we finally have proof that the James Webb Space Telescope can actually reveal information about not just the atmosphere and the composition of a typical planet, but also help us understand what's inside of it and analyze its core. Which means that it's very likely that in the next few years, by analyzing additional poofy planets and a lot of those other low-density planets, we might finally have more answers about how they form and why they exist in certain star systems, but not in others, and actually why these planets are somewhat rare and none of them exist in the solar system. Although I guess, at least for now, we can only assume that they do have different formation mechanisms, and not all of them are the result of a hot core. This one seems to be, but this mechanism is unlikely to explain the ones discovered in other star systems. Well, looks like we have a new record holder. A research team, whose paper you can find in the description below, discovered the most distant galaxy we've ever seen by using the iconic James Webb Space Telescope. The galaxy whose name and whose location you see right here, while also discovering another galaxy at a relatively similar distance and discovering why these galaxies exist so early on and what's actually happening here to begin with. And so, hello wonderful person, this is Anton. Today we're going to discuss a new record holder, talk about these early galaxies and what's happening inside of them, and I guess talk about whether this actually violates any of the known cosmological models, such as the famous Big Bang Theory. Although just to give you a bit of a spoiler here, the answer is no, not really. It's still good, everything here is fine. But what I wanted to start with is, of course, the video I made maybe a few years ago about the previous record holder we've discussed recently in one of the videos right there. This is the galaxy known as GNZ11, and this was the farthest galaxy we've ever seen. The galaxy that also possesses one of the most active black holes that you can learn more about in that video. But since the James Webb became operational, pretty much right away, researchers started to discover even more distant galaxies, with each new discovery beating old records. And a few months back, we've discussed this, JWST-13-0, a galaxy that was the most distant for at least a few months, and whose distance was confirmed by separate studies. Here this was a galaxy at a redshift of 13.2, and that existed when the universe was possibly only about 350 to 400 million years old. Although intriguingly, because of its unusually small size, and because it was kind of compact, one of the unusual propositions here was that maybe this was not the sign of a very distant galaxy, but instead a sign of what's known as a dark star, a hypothetical dark matter star that we've discussed in one of the other videos in the description. Either way, this was a really exciting discovery and a super exciting confirmation. And interestingly, if you convert this redshift to a physical distance, this is approximately 33.6 billion light years away from us. Now, I'm sure someone in the comments is going to ask, how is that possible if the light is only about 13.4 billion years old? And the answer is expansion of the universe. As things expand, they get longer and longer, and so the light from this galaxy traveled a much longer distance. But around this time, a lot of additional galaxies were discovered by other studies, with some even claiming galaxies that could be at a redshift of 17 or even higher, implying that they basically existed when the universe was much younger. But further analysis, especially analysis using spectroscopy, established that these galaxies just appear to be really far away, but in reality were much closer. And here's because the scientists, when they use spectroscopy, can usually establish direct distances with extreme precision. But by just looking at how red the galaxy is, sometimes we do get wrong results. And so basically, this galaxy was still a record holder for many months. It appeared to be the farthest, the most redshifted, with only one other galaxy even coming close. This was an object known as Uncover Z13, but it was probably just a little bit closer. But because many of these galaxies still lacked the spectroscopic confirmation, it was not clear if any of the other candidates were actually even farther. And well, it turns out that some were. And so this is pretty much coming from the same image, but of a different object. And here the redshift was established to be 14.32, or almost 100 million years before that other galaxy I showed you previously, implying that this potentially existed when the universe was only about 300 million years old, with the spectroscopy of elements inside this galaxy directly confirming the distance. And there was actually another candidate in this image as well, but this one might be just a little bit closer, despite the name suggesting otherwise. But one question you might be asking yourself is, okay, but how exactly do they know the distance? How can the distance be possibly so accurate? Down to a decimal point of the redshift. And here this is a really intriguing technique based on what we know about the early universe. If you've been on this channel long enough, you probably know that back in the days, and here we're talking about really back in the days, billions of years ago, the entire universe was covered in what's known as the neutral hydrogen. This is also often referred to as the Dark Ages, because during this time any kind of a high energy light, for example ultraviolet light or even X-rays, would actually strike neutral hydrogen, being absorbed by it, changing it into hydrogen ions, which basically resulted in a very strange phenomenon where a lot of light from various stars would only pass through this gas if it was not high in energy. So basically, if a typical star was emitting a lot of ultraviolet light, that star would be practically invisible. All of this neutral hydrogen would block its light until all of the gas around the star would ionize over time. And that's actually the period we also refer to as Reionization period. It very likely lasted for several 100 million years until all of the hydrogen gas finally transformed. And because a lot of early stars were extremely hot, producing a lot of UV light, most of them were basically kind of hidden. Which also suggests that by looking at very distant galaxies, their light would look a little bit different. Today we call these galaxies Lyman break galaxies because they all essentially possess an unusual drop in frequencies around the wavelength of a typical UV light. And that's because all of this hydrogen absorbs the light after this, only letting certain wavelengths through. And we know the exact frequency for this because it's usually referred to as the Lyman break. And well, by knowing this frequency, you can then start measuring exact distances to a lot of super distant galaxies by looking at spectroscopy of those distant galaxies, which is precisely what was done here. And here's that Lyman break for this galaxy. Basically here the Lyman break was redshifted as if this galaxy was at the redshift of 14.32. And there's really no other explanation other than this is a super distant galaxy whose light is being blocked by neutral hydrogen because it's in the early universe. With one of the studies in the description below going through exact details of how this was discovered by using the James Webb Space Telescope. But here the discovery was also surprising for other reasons, because these galaxies are super active. They seem to display evidence for extremely vigorous star formation, with all of those stars naturally producing a lot of ultraviolet light that's then shifted toward infrared visible to the James Webb. With this galaxy also being relatively large and actually really bright for a galaxy existing so early on. Although when we say large for a galaxy during this period, it's still just a fraction of the size of the Milky Way. With the main discovery in this case suggesting that all of this light is really produced by these active stars and not really some kind of a black hole in the center, as suggested by some other studies or as seen in other galaxies. So basically this is not a quasar, this is really just active star formation. But star formation happening at an extremely fast pace. And something very similar is seen in this galaxy as well. But obviously no one can explain yet how these galaxies are able to exist so early on, or basically 300 million years after the Big Bang, which was one of the initial puzzles first identified just over a year ago. As you can see in this particular image, there are actually a few galaxies that are really far away, and at least one of them, still a candidate, appears to be even farther. And so actually for many months, the researchers thought that maybe this too was a much closer galaxy and the initial redshift was calculated incorrectly. But by conducting additional observations by using a near-infrared camera and by using specific filters, they were able to remove all of the galaxies nearby, only leaving behind galaxies that were really far away. With all of this brightness basically coming from hydrogen, and even some of it coming from atoms like oxygen, implying that even enrichment of elements has already begun inside this galaxy. And here we basically have something like 500 million solar masses in terms of stars, with all of them extremely active and extremely bright. But these stars are pretty young. Most of them are just a few million years old, suggesting that all of this started very suddenly and basically all at once. And so that by itself already tells us that it doesn't actually violate modern cosmological theories as much as it basically presents a problem for modern theories in terms of galactic evolution. Or essentially this highlights that the models of galactic formations we currently use are most likely incorrect or incomplete. Galaxies seem to form very suddenly and extremely vigorously, and as another recent study discovered, can even acquire galactic bars much faster than we ever thought. Here this is a galaxy that's only a few 100 million years old and it already contains a typical galactic bar. And so galactic formation seems to be a new mystery. It looks like modern simulations lack something because whatever happened in the early universe was very fast, and all of these stars and all of these galaxies transformed much faster and much more actively than we ever thought possible. Here this is an idea known as rapid mass assembly and metal enrichment. But additional search in a lot of these images produced by the James Webb revealed no additional galaxies at farther distances, specifically at redshifts of 15 to 20. And so pretty much all galaxies in this image are extremely unlikely to be farther away. There does not seem to be any galaxy right now existing during a period less than 300 million years after the Big Bang. And so this is definitely a super exciting new record holder and an exciting discovery confirming what the scientists believe now for several months. Galactic evolution and star formation has to be reworked from the ground up, and modern computer simulations that usually tell us about how galaxies form definitely don't tell us the whole story just yet. In the last 2 years, since the James Webb Space Telescope started to release a lot of its data, quite a few discoveries have already raised a few eyebrows, with some of the most unusual discoveries so far basically being from the edge of the universe, from the location very far away from us at extremely high redshifts. And this is essentially what the James Webb is actually really good at, it's able to easily discover these very distant objects when the universe was only a few 100 million years old, and when stars and galaxies were still just forming. But one of the more unusual discoveries, and I guess one of the more controversial ones, was officially announced and officially published sometime in early 2023, and it can be summarized with this picture right here. Now you can actually learn the details in a few videos in the description below, but in a nutshell, it was a discovery of at least 6 different galaxies, specifically red galaxies, that seemed to be a little bit too massive and already existed in the universe 750 million years after the Big Bang. And these unusual 6 candidates had a lot of solar mass. For at least one of them, the solar mass was estimated to be 10 to the power of 10 or even a little bit higher. And that means that there were 100 billion solar masses in these early galaxies. Our galaxy, the Milky Way, is only believed to contain 60 billion solar masses. And our galaxy took approximately 13 billion years to develop. And so something here was not adding up. And almost right away, we had quite a lot of controversial claims that maybe the universe was actually much older, or maybe the Big Bang theory was completely wrong, or maybe these were not galaxies. And we've actually addressed quite a lot of these claims before, but just to give you a short version of all of this, back then none of this violated the Big Bang or even most cosmological theories, but did potentially present a small problem for how we believe galaxies form. Maybe there was some kind of an unknown or misunderstood way to form galaxies, turning them into giants almost right away. Moreover, additional studies actually discovered that there didn't seem to be a problem here. At least one of the simulations that was conducted shortly after discovered that all of these galaxies could be produced in modern simulations such as the one known as Renaissance. And so in some sense there was maybe no violation whatsoever. Moreover, maybe these were actually not galaxies after all. Some studies claim that these were some exotic, bizarre objects, possibly even filled with dark matter, or something else entirely, or maybe these were actually extremely massive black holes that, due to their massive accretion disks, produced similar emissions to a typical star-forming galaxy. And the thing is, all of those explanations could be possible. Because of the enormous distances, and because of the small size of these objects, it was practically impossible to tell what we're actually looking at. There were no individual stars, and there were no individual features anywhere, just certain emissions of certain light that could be used to determine what we're looking at. But only a few months after, separate teams actually did discover a bunch of really massive black holes in a lot of these regions, suggesting that the black hole explanation was possibly not that far off. Maybe all of these were individual black holes with just a few stars, but mostly extremely large and extremely massive accretion disks. And so we're not actually seeing starlight. Instead, we're looking at superheated gas producing various frequencies as it spirals around the black hole. And because many black holes do actually produce somewhat similar emissions, at least compared to a typical starburst galaxy, here this was anyone's guess. But nevertheless, these were still interesting objects, and the scientists behind this most recent study, you can find in the description, decided to investigate them more, in the process discovering something else super weird. And so, hello wonderful person, this is Anton. Let's discuss these discoveries once again, but also discuss what we still don't understand and still don't know. Especially because, ever since these observations, additional observations have been now conducted, and now researchers have just a little bit more information. With the first confirmation being that these are indeed extremely red, faraway objects that existed when the universe was 600 to 800 million years old, but in this case, they also found what seems to be signatures of old stars. Not stars older than the universe, but stars that potentially are millions of years old, once again implying that all of this formed super quickly. And something that I guess nobody expected. And this was actually done by conducting spectral measurements, which revealed certain properties for various stars in these galaxies. But on top of these ancient stars, there were also signs of supermassive black holes. They were probably 100 to even 1,000 times more massive than Sagittarius A star, the black hole in the center of the Milky Way. And so here once again we had these unusual early universe objects with very massive central black holes and potentially a lot of activity around them, which might have resulted in rapid formation of ancient stars. And though once again this doesn't break cosmological models, it breaks the models for galactic formation and the growth of supermassive black holes. It was always believed that black holes and galaxies more or less grow together, but these observations suggest that this is not the case. black holes potentially controlled everything early on and possibly forced a lot of galaxies to grow around them, which included stars forming very early and very rapidly in an extremely active dynamic environment that we just don't understand. Either way though, this currently confirms what the scientists refer to as the earliest signatures of ancient starlight. The starlight that, to some extent, is still kind of difficult to explain. And here the spectral analysis pretty much confirms that these are galaxies with black holes and star formation, unlikely to be unusual exotic objects or something else that was claimed previously. But the actual properties don't make sense. The black hole is way too large, the stars are a little bit too old, and all this can only be explained if these galaxies formed super fast. But that's actually the explanation that a lot of scientists are now leaning toward. Something in the early universe forced everything to basically produce a lot of stars quite rapidly, and that something could have been the existence of these very massive black holes that were essentially all over the place. But once again here, because of the distances, we still actually have trouble seeing details. This could still actually be normal mass galaxies with extremely massive black holes, which would be much easier to explain. But there's actually something else that's very surprising here. And it's basically the mass combined with the size, which really does not make sense at all. Or at least it doesn't make sense for now. Here what we're actually looking at is really small in size. These are at least 1,000 times smaller than the Milky Way galaxy, possibly only a few hundred light years across. But they seem to contain just as many stars as the Milky Way galaxy, with possibly up to 1 trillion stars in them already. Now these are just speculations, but these are definitely massive objects. And by containing so many stars in such a small volume, we're literally looking at very exotic, very unusual objects. Now maybe these are just proto-galaxies that no longer exist, or maybe these are seeds for all galaxies out there, including the Milky Way. Either way though, pretty much most stars in this galaxy would actually be extremely close to the super powerful central black hole. And so here a typical region might resemble something we find in a typical globular cluster, with some of the farther stars only 50 light years away from the central black hole. And that once again confirms that whatever happened here happened super fast, extremely suddenly, and using phenomena and mechanisms we don't understand. There is currently no explanation and no model that can easily explain the formation of these bizarre objects. The objects that don't even have a name yet. And though I guess these are galaxies, they're also possibly not. Because for some reason, we know that none of these objects exist anymore, and the universe stopped forming these after just a few 100 million years. But because they're so mysterious, there are now going to be additional observations in other frequencies in order to find out what they actually are. Here the focus is going to be on the absorption signatures, just to see what kind of elements they contain, and to discover the details of the activity within them. In just over 2 years, James Webb Space Telescope has been able to make some really incredible discoveries, providing us with incredible images we've never had before, but also showing us the distant universe in a way we could not imagine. And even during the first year of its observations, it started to make some groundbreaking discoveries that could not be possibly seen by the previous telescopes such as Hubble. And some of these strange, hard to explain discoveries have been explored in previous videos you can find in the description below, but today we're going to discuss one that just keeps coming back. Because with every single observation, due to its extreme sensitivity, James Webb has been continuously discovering a series of unusual little red dots in various regions of the night sky, visible in pretty much every single image and present in numbers that's very difficult to ignore. And though obviously the initial assumption was that these were probably ancient galaxies, after multiple observations and a lot of different studies, a lot of researchers are actually not certain anymore. And so, hello wonderful person, this is Anton. Today we're going to discuss a few more studies about these bizarre objects, talk about what we actually know and don't know about them, and basically discuss little red dots. And that's essentially the name that was given to these objects, because currently it's not really known what they are. And here let's start with this. This graph shows us a kind of a timeline of modern astronomy. Here you can actually see that up until late 1960s, we've mostly been aware of various galactic clusters and extremely bright galaxies in the vicinity of the Milky Way, but could not really see that far back in time.
Then, in the early 1970s, this was the birth of radio astronomy, and this is essentially when we discovered quasars. Extremely bright objects, powered by supermassive black holes, but whose brightness was the result of an extremely massive and extremely powerful accretion disk orbiting the black hole. And also, of course, the jets that seem to be produced as a result of the magnetic field inside the accretion disk. And then eventually, in the early 2000s, we actually even started finding galaxies that were so far away that they were still hidden by the neutral hydrogen, or essentially they were present when the universe was still not ionized during these so-called cosmological dark ages. These were known as the Lyman break galaxies, and they were first discovered by the Hubble Space Telescope and then later on by Subaru and Makemake telescopes. And now, in the 2020s, we've reached a new era. The era of JWST that essentially allows us to see even further. But at this point, we're not even certain what exactly we're looking at. But based on previous observations of various quasars, since both seem to appear as red dots, these discoveries from the James Webb were possibly assumed to be something similar. Maybe massive black holes, maybe distant star-bursting galaxies, or maybe signs of super powerful galactic collisions. But whatever it was, it seemed to be everywhere. These little red dots were first discovered in the Eiger survey, emission line galaxies and intergalactic gas in the epoch of Reionization, and also in the Fresco survey, that stands for First Reionization Epoch Spectroscopically Complete Observation, the two surveys whose purpose was to basically find a bunch of galaxies super far away. And while initially, as more and more of these objects were discovered, the obvious first explanation was supermassive black holes. So basically something similar to a quasar, but just a little bit farther away. And in the last 2 years, we've actually did discover a few quasars at really far away distances in the first 700 million years after the Big Bang. And so maybe these red dots were somewhat similar, just not as impressive. So in other words, maybe these red dots were just smaller versions of these extreme quasars. And while by observing a few of them in a little bit more detail, some of them actually did possess what the scientists refer to as a wide line profile. Specifically, this refers to the hydrogen line, with the width of the line suggesting that this gas is just moving extremely fast around something, implying that it was orbiting some kind of a central massive object. And so because of these signs of a small hydrogen gas cloud moving extremely rapidly, the implication here was that there must have been a supermassive black hole in the middle, but black holes that have not actually formed a coherent accretion disk yet, and for the lack of better words, were just baby quasars. We've actually discussed 3 such objects discovered recently, and you can find this video in the description that talks about this a little bit more. And so if correct, this would imply that eventually all of this dust would disappear, and these obscured massive black holes would probably become typical quasars. But obviously not everyone agreed with this interpretation, especially because other studies discovered other stuff. For example, separate studies discovered that there's a lot of extreme, very intense starburst activity consisting of very young stars less than 5 million years old. And this was also seen in a lot of spectroscopic data, with the overall energy production possibly coming from extremely powerful OB stars, with only some contribution from the central black hole, with both sets of studies providing just enough evidence to suggest that these red dots were either super compact galaxies full of incredibly powerful stars, or very compact objects surrounded by dust but hiding massive central black holes. And there was enough evidence for both. But I guess what's even more surprising is that these were everywhere. Hundreds of these objects were discovered in just the first year, and more were found in every single new image, with every new discovery making these little red dots even more mysterious. Mostly because they just didn't really make sense. As a matter of fact, some of them were so bright and so luminous that technically they shouldn't even exist. If these were black holes, they were basically consuming way more mass than black holes can consume, and if these were starburst galaxies, for some reason they were producing way more light and way more energy than anything we've ever seen. And though obviously, maybe this is something in between, and maybe this is just a combination of both of these, so basically black holes and starburst galaxies, the issue here is that both of these explanations actually contain fundamental problems. For example, if all of this is formed by powerful starlight, then these objects are producing so many stars and at such a high rate, it would actually produce modern universe that's way too massive compared to what it actually is. In other words, if we basically estimate the amount of mass produced here by these little red dots, they would produce the universe that's just unrealistic. In contrast, if all of this is a result of black holes, then these black holes have to be gigantic, way bigger than expected, and representing masses way more massive than the actual galaxy. Now, if you watched the previous video, this was basically the conclusion we came to in that video, because it's the only one that didn't seem to break a lot of rules. But the problem here is that we don't actually have an explanation for how these black holes would form or where they came from. The only way for these black holes to be possible is to basically form supermassive right after the Big Bang. And that also creates a bunch of problems, especially for our assumptions that the universe should be more or less homogeneous everywhere. It should not have these supermassive chunks suddenly appearing out of nowhere. And so at the moment we just don't have an explanation that fits well with all of the models we have and with the observations we're getting from the James Webb Space Telescope. So something here is still missing. And so far, no one out there has been able to explain any of this, even though so many people have tried. But because these little red dots are literally everywhere, and because they have these strange properties, this is probably the biggest and the most important mystery coming out of James Webb in the last 2 years. As a matter of fact, the mystery here gets even more intense as you start analyzing the stars. As we've discussed in that previous video, for some reason many of these little red dots contain stars that possess old age. Basically stars that are hundreds of millions of years old, suggesting that all of this formed literally all at once, possibly 200 to 300 million years after the Big Bang. And because of this unusual, sudden, instant formation, it's somewhat difficult to explain. It's not how stars form today, and it's definitely not something we see around us in any of the nearby galaxies. And on top of having old stars, they're also surprisingly dim in the X-ray wavelengths. That doesn't make sense if they contained a lot of powerful objects, such as black holes and starburst regions. In modern universe, these types of objects usually contain huge amounts of X-rays. Here though, not so much. And so because we keep finding more and more of these objects everywhere, and because they seem to be so strange and so difficult to explain, a lot of researchers are now basically focusing on trying to conduct more observations and conduct spectroscopic analysis of what's inside of these little red dots in order to finally explain what's up. But for now, for I guess at least a few more months, this is just going to remain a mystery. A mystery that I'm sure is going to be solved in the next few years.
Well, looks like James Webb Space Telescope discovered yet another unusual galaxy. A galaxy that you can kind of see right here, that for the first time ever is showing us what's known as the Lyman alpha line, or basically a very specific emission of light produced at extremely faraway distances when the universe was only about 330 million years old. But why exactly this galaxy is doing this, and why this light is visible, is basically this new mystery. And so, hello wonderful person, this is Anton. Let's discuss why this is a mystery and what exactly this means, and at the same time, basically learn about a lot of these early galaxies and how they appear very different from any galaxy around us. But first, so what exactly is this Lyman alpha light, and why exactly is it important? Well, when it comes to very early galaxies, or essentially baby galaxies that just started forming, today we believe most of them were essentially what's known as Lyman alpha emitters, or they were basically emitting Lyman alpha radiation from neutral hydrogen. And this is a very specific type of light at approximately 121 nanometers in wavelength that's produced when the electron inside the atom of hydrogen transitions from one state to another. And specifically this is caused by a neutral hydrogen that was pretty much everywhere in the early universe, transitioning into ionized hydrogen when something acts on it, such as for example very powerful light from various star-forming regions. And so as a result, whenever we actually see this light coming from a galaxy, it usually implies at least two things. First, it means that this galaxy is located in a region with a lot of neutral hydrogen in the extremely early universe. And second of all, this galaxy seems to have a lot of star formation or some other means of producing powerful radiation, potentially containing some of the highest star-forming regions in the early universe that are actively reionizing regions around this galaxy, literally showing us the process of reionization as predicted by modern cosmology. But when it comes to these Lyman alpha emissions and these Lyman alpha galaxies, This particular emission line has never been seen earlier than 550 million years after the Big Bang. And that's because despite being super energetic and containing a lot of emissions, when looking at super distant universe, there's just so much neutral hydrogen everywhere that even this light does not get through. And so in most cases, what we usually see are essentially galaxies usually missing a lot of frequencies of light. For example, there's another type of a star-forming galaxy, known as the Lyman Break galaxy, that will appear something like this. It's as if any photons that contain ultraviolet light, or even more energy, completely disappeared. And this is actually what it looks like if you were to look at this galaxy in different frequencies of light. Here's actually one example from JWST, a galaxy known as Uncover Z13. And this of course proves to us that this neutral hydrogen was pretty much everywhere for the first billion years, and made a lot of galaxies appear very differently. But extremely distant energetic galaxies, especially the ones containing a lot of star formation, produced very powerful emissions that eventually got through and possibly even reionized the rest of the universe. But because we actually expect more and more neutral hydrogen to exist as we go back in time, we obviously don't expect to detect certain types of light at certain distances. But this time researchers discovered something they once again did not expect at all. Here we have the 5th most distant galaxy ever discovered that seems to definitely possess an extremely bright hydrogen emission line that should be otherwise invisible. And unlike previously discussed galaxies that usually contain this Lyman break, with basically emissions of hydrogen practically invisible, in this case we definitely have a galaxy where the hydrogen emission is visible at just 325 million years after the Big Bang. And in this case, it's seen as this really large line sticking out in all of the other wavelengths. And though at first it was not clear what exactly this shows us, because of the redshift, it was actually confirmed to be a hydrogen emission line of an extremely faraway galaxy. And once again, the reason this is unusual is because the universe was supposed to be opaque because of all of this neutral hydrogen. This line should not be visible. And so basically here, something in this galaxy is making all of these electrons drop down in energy and produce a photon of an extremely specific ultraviolet energy. And somehow all of this light got through this fog and reached planet Earth. And so detecting ultraviolet light at a redshift of 13 is currently not really easy to explain. Now the previous record holder was detected at a redshift of 7, so this is when the universe was about 600 million years old. But detecting it so early basically presents us with a new cosmological dilemma. The dilemma is so big that the scientists at first thought that maybe this was actually a mistake. This had to be confirmed several times, and we now have direct confirmation that this galaxy is indeed real and is indeed so bright at these very specific frequencies. One of the primary researchers, Kevin Heinlein, posted this image showing us what they were able to observe. Out of 19 observations using 19 different frequencies, here we're only seeing this in shortest wavelengths. And that of course proves to us that there is a lot of neutral hydrogen here and it completely blocks certain types of light. But even though it's brighter at longer wavelengths, it's still able to produce this bizarre emission. Lyman alpha hydrogen emission line is unfortunately not visible in this image because it's actually right between two filters. And so even though there is no explanation for now, there are maybe some suggestions. Now the first and most exciting suggestion was that this was maybe the discovery of the mysterious population 3 stars, or basically the first stars in the entire universe. These stars would be very, very unusual, very bright, very powerful, and potentially create so much brightness that it could maybe shine through everything. But it's unlikely to be the case because here we don't really see other predictions, such as for example specific observations from emissions of helium. And so because we also see emissions from carbon, oxygen, and a few other things, right now this seems to be just a regular starburst galaxy. And because in this case the emissions themselves also seem to be slightly wider than usual, these broad emissions could be because of some kind of a really hot plasma or possibly some kind of a fast motion. So maybe things spinning around in the accretion disk, or maybe a lot of motion of gas inside some kind of a very powerful star-forming region. And so the only, I guess, not so satisfactory explanation right now is that this galaxy seems to be located inside some kind of a reionized bubble. The bubble that appeared extremely early on, as you see in this simulation, and produced a large volume around the galaxy that then somehow allowed this light to seep through to one day be visible from planet Earth.
So essentially by being inside this unusual bubble, it prevented a lot of this light from being absorbed. But that's just one of the potential explanations, and right now there is really nothing else we have, except that this is a super unusual galaxy. A galaxy that will probably help us explain reionization a lot better, and help us understand the early universe a lot better as well. And so maybe reionization just happened a lot earlier in certain locations, and produced somewhat unusual and somewhat unexpected shapes or volumes of space that allowed some of this light to seep through and to be visible through all of this unusual fog. And chances are, just like with other galaxies discovered by JWST, this mystery is going to be solved pretty quickly as well. As a matter of fact, we just recently covered several other mysteries already officially solved, such as the bizarre little red dots or little red dot galaxies that were also discovered by the same survey just over a year ago. One of the main missions for the James Webb Space Telescope is to try to discover first stars in the universe. The so-called population 3 stars that scientists believe existed billions of years ago and over time led to the formation of other stars that we usually refer to as population 2. And because these first stars would be made out of pristine hydrogen, and because they could also get to extremely large and massive sizes, various types of models have already established what we should be seeing if we actually ever find these stars. Specifically here, we would be looking at regions with some of the hottest objects known to us, possibly at least 120,000 Kelvin and at least 50 solar masses. And these types of stars would also cause tremendous illumination of gas around these stars, forcing this gas to basically shine super bright. And well, it turns out that extremely recently, researchers might have actually discovered something super unusual in a galaxy far away. By once again conducting very detailed observations with the James Webb Space Telescope, scientists discovered the galaxy you see right here, GS NDG 9422. A galaxy at a redshift of 6, or essentially existing when the universe was only approximately 1 billion years old. But in this case, something was super unusual. The light coming from this galaxy was not really coming from stars. Turns out that most of the light in this galaxy is essentially glowing gas, similar to a typical fluorescent lamp. Something was causing the gas in this galaxy to glow super bright, much brighter than any star in it. And this was super strange. And almost right away, the initial assumption was that, okay, maybe we finally found them. Maybe this is actually the result of these first stars, or population 3 stars, and maybe the James Webb Space Telescope finally discovered them. And well, hello wonderful person, this is Anton. Let's discuss this galaxy in a little bit more detail, find out what's actually happening here, or at least what we think is happening, but also let's start with a little bit of history. Let's go back 20 years. 20 years ago, when the telescopes were still not as developed, researchers got super lucky by observing something with the Hubble Space Telescope and discovered an unusual formation we now refer to as the Lynx arc. This was actually only detected because of powerful gravitational lensing effects, but in essence it revealed something super strange. It revealed what seemed to be the hottest known star-birthing region in the entire universe. The region at a redshift of 3.4, or when the universe was about 1.8 billion years old, and the region that seemed to contain millions of O-type stars with masses over 50 solar masses. In contrast, the nearest star-forming region with a lot of massive stars near us is right here. This is the Tarantula Nebula, and here we actually only have a few hundred similar stars. Some of the most massive and some of the brightest stars are all found right here. Yet the Lynx arc seemed to suggest something several thousand times more powerful and of course more massive. A region approximately 1 million times brighter than a typical nebula, and a region that was also much hotter than anything we've ever seen, which is why it was named the hottest region in the observable universe. Now we don't actually know what it looks like because it's kind of far from us, but this was an artistic representation. And well, back then this was assumed to be something that was very likely extremely common in a lot of these early galaxies. It was referred to as the furious firestorm of starbirth, a kind of a possibly short-lived stage where many different galaxies would suddenly become extremely bright and extremely powerful, possibly lasting for several million years.
And though at first this was assumed to be population 3 stars as well, it turned out to be something different. Here, an average star temperature was only about 80,000 Kelvin, which is, though much hotter than what we usually find in a typical galaxy, was definitely not as hot as population 3 stars are expected to be. But this was still a really important discovery of the first super hot region, producing an enormous amount of ionizing radiation, very likely powering a lot of nearby nebula and causing them to have certain effects. And up until this point, this remained to be the only such example. But now the scientists discovered something that seems to be possibly even more extreme. The study by Alex Cameron and his team revealed not just a single star-forming region, but the entire galaxy, where the gas from nebula outshines all of the stars. And this extremely strong nebular emission currently does not have a very good explanation. Now there are some explanations, but overall we basically have no idea what's really happening here, or which model seems to be correct. But the biggest question is, could this finally be the sign of these population 3 stars, first stars in the universe? Well, the researchers behind this paper don't believe so, and for really just one main reason. The overall spectral emissions, even though it seems to suggest metal-poor stars, still seems to come from stars of second population, because a lot of them show a lot of chemical complexity and various elements not expected to be present in the first stars. Nevertheless, these emissions are also different from a typical star or from stars we're usually familiar with. In other words, these are still exotic stars and can actually help us understand how galaxies transition from primordial versions to a lot of modern galaxies, or help us understand what happened in these early galaxies in the first billion years. And so after a several months long analysis, we now know just a little bit more about what's happening here. And so once again we have these really high temperatures, with very hot stars possibly 100,000 Kelvin in temperature, which is hotter than previously detected Lynx arc, but not as hot as population 3 stars, with a lot of these stars producing huge amounts of ionizing radiation that seems to power an extremely bright glow from a lot of gas in a galaxy. And weirdly enough, all of this glow dramatically outshines all of the stars in this galaxy and everything else around it. But obviously in this case, it was not entirely clear if it's actually stars doing this. One of the first assumptions was that maybe this was a central black hole that's basically causing all of the gas around it to glow super bright. And technically this is still one of the potential explanations, but the emissions coming from here don't resemble a typical black hole. Whereas other models trying to explain this using some kind of a reflection, or possibly some kind of a structure around the star, do not explain everything as well. But if this is coming from extremely hot stars, surrounded by a typical gas in a typical galaxy, a lot of the emissions seem to match the observations almost exactly. And so here we have a typical low density and low metallicity environment usually found in various nebula, but with ridiculously high temperatures, extremely likely powered by very hot, very massive stars, which basically results in the production of never-before-seen light spectrum coming from a distant galaxy. And so gas outshining stars caused by the stars themselves seems to be the best explanation, which of course confirms some of the earlier predictions as well. We expect early universe to contain a lot of massive hot stars in very large numbers and in somewhat tight arrangements, with many of these stars forming specific regions that would then cause reionization of the entire universe by producing enormous amount of energy. But as we know today, these environments can actually no longer exist just because the universe transformed so much. And so in the local universe, a typical hot massive star is only going to be about 40 to maybe 50,000 Kelvin as opposed to 100,000 detected here. And we're also unlikely to see millions of these stars in the same star-forming region like we see in this galaxy. But because this is the only such object discovered by the James Webb, it's assumed to be a relatively brief phase that's most likely going to stop within a few million years. But because this is also one of the predictions about population 3 stars, or potentially also explains why the early universe seems to be so different from the modern universe, because of studies like this, we're actually only getting closer and closer to various solutions in regards to the beginning of the universe, the formation of early stars, and the evolution of early galaxies. And so far, despite of these anomalous discoveries, everything to date kind of actually makes sense.
Somewhere out there, on the outskirts of the solar system, there's a very peculiar object, technically a dwarf planet, known as Makemake. We don't really know exactly what it looks like, but it's probably something like this. Although we do know that compared to other dwarf planets, it seems to be just a little bit more red. The result of interactions between methane on the surface of Makemake, along with other carbon-containing compounds, and the reactions from ultraviolet light and cosmic ray radiation, which actually results in something known as tholins, and these tholins make things extremely dark red in outer space. But the thing is, because of recent observations from the James Webb Space Telescope, researchers have actually started making some really unusual and unexpected discoveries coming from several of these dwarf planets, but specifically Makemake. And today we're going to discuss one of these discoveries that was just discussed in the paper in the description that essentially confirms some of the speculations from before. A lot of these worlds seem to be ocean worlds, and many of them are still geologically active even today. And that means there's maybe a slight chance that many of them might contain life. And so, hello wonderful person, this is Anton. Let's discuss some of these new discoveries, but first let's do a bit of a review from a previous discovery that was announced back in February of 2024. Here this was a James Webb observation of Eris and Makemake, which might appear different, turn out to be extremely similar in one important feature. As the study by Christopher Glein and his team revealed, based on observations of types of methane on the surface of these objects, which were visible to the James Webb Space Telescope, it became apparent that the only way this type of methane could be produced was if basically it came from within these objects. Or just to rephrase this, it was evidence for some kind of a cryovolcanic activity, possibly geologic activity, that would bring up some of the stuff from within these objects and then deposit it on the surface. So kind of similar to what's happening on Enceladus, where there's a lot of cryovolcanism, and a lot of materials end up on the surface afterwards. But obviously here there was maybe one difference. The difference is that these objects were super far away from the Sun, and moreover, were not actually orbiting anything massive. For objects like Enceladus and for other objects that potentially contain liquid oceans, since they orbit giant planets, and since they do have a lot of partners and quite a lot of neighbors, there's a lot of tidal activity that can actually give them energy to then produce these volcanoes. That's of course how, for example, volcanoes on Io are powered as well. Yet Makemake is basically farther away from the Sun than Pluto and only has a tiny moon in its orbit that's extremely unlikely to be able to produce any of these effects. Eris is even farther away and does not seem to have any moons. So the question is, what's happening and how is this possible? And so if you'd like to learn more details, the video in the description talks a little bit more about this, but in a nutshell, it was basically assumed that these objects very likely had substantial rocky cores that at some point, and possibly even today, produce radiogenic heating, which is exactly what's happening inside Earth as well. And because of this heating, they would thus have much warmer insides, resulting in massive oceans within them, and also resulting in the production of various carbon molecules, including specific types of methane, which by itself was an intriguing discovery and an intriguing explanation. But now, just a few months later, we actually got a new observation and even further analysis, this time coming from a study by Sabakis and a team from Europe that observed Makemake by using mid-infrared frequencies. And to their surprise, they actually found an excess of heat coming from Makemake, suggesting temperatures of about 150 Kelvin, which sort of made no sense. Or I guess let's rephrase this. Because of the distances, here Makemake is expected to be only 40 Kelvin on the surface, yet James Webb was able to see hotspots at least 110 degrees warmer, which could not have been produced by any kind of a solar emission or even any collision, except for maybe two things. Here, the first explanation suggests that maybe the subject contains a relatively small ring filled with carbonaceous dust grains, once again kind of similar to what we actually observe around Enceladus. There's actually this gorgeous shot from the Cassini mission that shows us how all of this dust produces E-ring around Saturn. And so this dust could possibly produce these temperatures. There is maybe one problem though. First of all, it's actually unknown where it came from, and second of all, previous observations from 2011, when there was a star occultation that allowed researchers to actually see what's happening close to Makemake, did not reveal any additional rings. although technically here they were looking for the atmosphere, which was also not discovered either. And so if the occultation did not see the rings, obviously the rings could have been really small, or this heat could also be formed in a different way. And specifically, these heat spots could be actually showing us a continuous eruption, very likely powered by some kind of a subsurface heat, and in this case, very likely covering at least 1% of the surface of Makemake. In other words, one of the better explanations for this unusual hotspot is of course cryovolcanoes. Very similar to what we've seen many times around other objects in the solar system. And if so, this would actually explain both the presence of methane, the presence of additional particles that could be producing some of these emissions, and might even explain any kind of a tiny ring that could be discovered at some point. In other words, this is essentially the first evidence we have for active geologic activity, or for some kind of an activity extremely far away from the Sun around the object that does not actually have anything massive around it. No major planet, no major partner that can actually do any of this, and the object that's at least 4.5 billion years old. So in other words, it looks like Makemake potentially stayed geologically active for an extremely long period of time. And if correct, and if confirmed, this is obviously a huge discovery. It potentially suggests that many of these objects contain vast underground oceans, many of them contain organic molecules, potentially giving life a huge chance to start anywhere. And more importantly, this discovery rebukes previous assumptions that suggested distant objects would be completely uninhabitable. Here, if this is confirmed, and if this is indeed cryovolcanism, it does imply Makemake and a lot of other objects, a lot of other dwarf planets, could indeed be hiding life somewhere inside. Although obviously if this is just the rings and not cryovolcanoes, it would point at an additional phenomenon we don't really understand, suggesting that trans-Neptunian objects potentially have a lot of other geological effects we barely understand. But trying to study this more, or trying to understand this, is going to be really challenging, mostly because Makemake is super far away and nobody is really planning any missions there anytime soon. But there's maybe one way to study this without going there directly, and that's by comparing it to an object that we have studied very well, Ceres. Now there's still a bit of a debate about where exactly Ceres came from, and specifically where exactly it was formed, because it's actually very different from all of the other asteroids in the asteroid belt. But right now there is an assumption that maybe Ceres was also created in a very similar location to Makemake and Pluto, and eventually somehow got transferred to the asteroid belt. And as you might know, Ceres was one of the worlds that NASA studied extremely thoroughly with the mission known as Dawn. And here we also discovered ammonium-rich deposits and also signs of ancient cryovolcanism as well. For example, there are a lot of unusual white salt deposits discovered around different craters, with their origin pointing at ancient cryovolcanism. But here it potentially ended millions of years ago, possibly even over 100 million years ago, at least the larger cryovolcanoes like Ahuna Mons. Nevertheless, discoveries from Ceres point at the geologically active world with various mountains, domes, fractures, and a lot of other unusual objects, all indicating that something within Ceres was producing heat that would then be released on the surface. And there are also signs of potentially ancient ocean that now might no longer exist, but it could have existed for billions of years. And so because Ceres seems to show signs of water flow and the presence of a lot of different complex molecules on the surface, assuming that it came from a similar region to Pluto, Makemake, and Eris, we can kind of speculate that maybe they actually have very similar geological activity inside, and maybe they all, at some point, hosted an ocean world. A world filled with a lot of organic molecules, but obviously trapped by all of the ice on the surface. And though now the speculations about Ceres basically suggest that it might still have some liquid water inside, but just trapped in much smaller pockets, no longer a large global ocean, for objects like Makemake, since it is more massive and thus potentially contains a larger core, it could imply that it's still active even today and might thus still be able to support life. And so here the idea is that by studying Ceres, we might be able to figure out what's actually happening on Makemake and other dwarf planets like Pluto as well. But it will probably take years before we can actually come to any conclusions. And the best way to have any of these conclusions is to maybe organize some kind of a different mission, kind of similar to the New Horizons, but this time possibly placing an actual probe on the surface of these dwarf planets in order to figure out what's on the surface and what's inside. But that's obviously wishful thinking. Right now there's no talk or even suggestion of talks about such a mission, and so for at least another decade, we're definitely unlikely to know more. Hello info person, this is Anton, and today we're going to discuss a somewhat unusual mystery uncovered by the James Webb Space Telescope when it took a look at the Orion Nebula sometimes in 2023. We've actually discussed these discoveries in some of the previous videos in the description, but basically in these absolutely incredible images, something really bizarre and something very unexpected was discovered almost right away. And you can see these unusual discoveries right here. Today these are known as jumbos, Jupiter mass binary objects that for some unknown reason were all over the place inside the Orion Nebula. And this particular observation from the Orion was already quite surprising. And surprising because of a discovery of hundreds of different free-floating planets, or FFPs, that were actually hiding inside the nebula this whole time. Now, some of the original FFPs, which we also sometimes call rogue planets, were first found by the infrared telescopes approximately 20 years ago. But because since then the telescopes improved dramatically, researchers discovered hundreds more. And so here we basically are talking about planets which don't actually have a parent star and may even have their own mini-planets, or I guess mini-moons, forming their own individual systems. As a matter of fact, we got so good at detecting them that recently, just a few months ago, even the TESS telescope, that was actually never designed to discover these planets, found one by accident. Here this was a result of a gravitational lensing effect, as one of these objects, approximately same mass as planet Earth, passed in front of a distant star. And so basically tons of these rogue planets have now been discovered, and many of them are still mysterious, with the biggest mystery being their origin. We don't really understand how exactly they form. But last year, in this study you can find in the description, James Webb was able to discover approximately 500 such objects hiding inside the trapezium cluster in the Orion Nebula. But out of these 500 objects, 42 came as pairs. And all of these pairs were very similar and super bizarre. They were between 0.7 and 13 times the mass of Jupiter, with all of them forming an unusual binary. So basically here we had 84 objects that formed 42 individual binaries. But we've never seen anything like this before, and this had absolutely no explanation. As a matter of fact, the simulation I usually use for a lot of videos, Space Engine, basically added all of these objects almost right away, just because this was such a bizarre and such an unusual discovery. You can actually see some of these objects right here, and you can then travel there just to see what they kinda look like, as visualized by this simulator. Although because many of these objects are relatively massive, they're also probably going to be somewhat hot. As a matter of fact, so hot that they're easily visible in the infrared. And though initially researchers thought that maybe these are basically kinda like brown dwarfs that we've seen before, turns out that they're not. They actually seem to be completely different objects we've never seen before, as recently proven through another observation. Here, by using a radio telescope, and specifically the Very Large Array, astronomers focused on one of these objects, Jumbo 24, discovering that it's also very bright in radio light. In other words, unlike your typical brown dwarf, or I guess unlike a typical planet, these objects were also emitting a lot of radio light for reasons unknown. And the radio light coming from these objects was much higher than anything from a brown dwarf or from a typical planet. And so this somewhat bizarre observation raised a lot of questions about their origin, or even what these objects are. Specifically here, there was even a kind of a correlation between the infrared brightness and the brightness in radio light, with researchers confirming that this relationship is extremely unlikely to exist completely by chance. And the overall conclusion from the study in the description basically being we need more observations and more analysis to try to figure out why we see these objects in radio waves. And so here to explain these objects, we only had two potential scenarios. One scenario is that these used to be planets or maybe brown dwarfs present in larger star systems, and eventually, because there are so many stars around the system, some of the neighboring stars might have kicked them out of the system, basically turning them into rogue planets or individual planetary systems. But the other scenario was a little bit different. Maybe these objects were born this way and collapsed directly from primordial gas, but just did not have enough mass to form stars. And because we know many different stars are usually formed as binary objects, it would explain why we have 42 binary rogue planets. But basically for the past year and a half, researchers have been trying to figure out how exactly could they form. And one of the initial studies basically revealed that if these objects were actually captured from a different star system and were previously planets orbiting around those stars, statistically it would not make sense that they would be binary objects. In other words, it's extremely unlikely that binary systems would be physically captured from a typical star. And so here, by running thousands of simulations, usually involving different planets and different stars with a lot of massive neighbors, all of the calculations suggested an extremely low probability, less than 1%, that a pair of planets would be kicked out of a star system. And in those cases where they did get kicked out, those planets would only be about up to 4 times as massive as Jupiter and would have to be neighboring planets at first. But these jumbos are way more massive on average, which actually would be difficult to explain. In contrast, it was relatively easy to lose a single planet, so some of these single rogue planets could be explained this way. Basically, a stellar flyby can technically create a rogue planet, just maybe not a binary planet. And the conclusion from this initial study was that it looks like the origin of these objects might be a collapse after all. So basically they collapsed from some kind of a gas, turning into individual binary objects. But the question here was, why are they actually so small? And why have we not actually seen these binary objects ever before? And well, this is where we get this new study that potentially explains it through a slightly different approach. And so in this most recent study, Jessica Diamond and Richard Parker potentially explain this using a slightly different phenomenon, a phenomenon known as photoerosion. And the idea here is really simple. Basically, we do start with a lot of gas collapsing into various objects. Some of them are going to be binary stars, and some of them are going to be really massive stars, spewing out huge amounts of gas and even producing huge stellar emissions. Here's actually one of the simulations known as the Starforge collaboration, showing us how we usually think this happens. And we know that in the Orion Nebula, there are a lot of these really powerful stars, so-called OB stars. Very, very hot, very massive stars, but usually with relatively short lives, that produce enormous emissions, ionizing a lot of nearby gas, and even creating what's known as the Stromgren sphere around themselves. Stromgren sphere refers to the unusual spherical object containing ionized hydrogen very often present around young stars. One of the best examples is the Rosetta Nebula, but many different really hot stars around us will actually produce these as well. And so in this study, researchers basically investigated what happens to various objects, specifically binary objects, as they collapse close to these OB stars. And turns out that the radiation from massive OB stars can dramatically inhibit star formation by blasting enormous amount of radiation and stripping away huge amounts of gas from the outer layers of these newly formed jumbos. And so this process of photoerosion could actually be directly responsible for why these objects end up really small. They were supposed to be large stars, but they were basically born next to a bully. A super hot, super powerful star that strips everything from the vicinity, leaving only small binary objects behind. And this would actually explain why we have so many unusual small binary objects, and even why they seem to possess unusual emissions we don't normally see from planets. Basically, these were really supposed to be stars, but they just didn't succeed. So yeah, failed stars by definition. With the only thing missing in this explanation being the difference between these objects and brown dwarfs. Because here the radio emissions still don't really make sense. But right now this is still the best possible explanation we have for why these exist, and here the researchers even provide exact mapping showing us ionized regions around 6 massive stars in this location, where many of these jumbos seem to be present. So basically there's a bit of a correlation between a neighboring massive star and the presence of a jumbo. But naturally this is just the first explanation, and chances are that only additional observations using radio light and more observations from the James Webb will be able to explain what's happening here. Today we're going to discuss a somewhat unexpected discovery in regards to supermassive black holes. A discovery that basically proves how they seem to grow. And in this case, we don't just have a theoretical explanation, we finally have physical proof. A proof coming from the James Webb Space Telescope that essentially shows us how some black holes are able to achieve incredible masses in what seems to be an extremely short time. And so, hello info person, this is Anton. Let's discuss this recent study by Hewon Saw and her team that was able to discover an unusual black hole relatively far away from us, that to everyone's surprise seems to be consuming an enormous amount of mass, way more than we ever thought possible. As a matter of fact, 40 times more than theoretically predicted should be possible for a typical black hole. But first, why exactly is this unusual, and what exactly is the mystery or the question scientists are trying to answer? Well, first of all, here we're only talking about supermassive black holes, the black holes in centers of various galaxies that sometimes produce enormous emissions. And because of new telescopes, including the James Webb, in just the last couple of years, so many discoveries have been made about extremely distant black holes. For example, very recently, researchers accidentally discovered a black hole that is actually slowly awakening, becoming an active quasar. This was actually discovered completely by accident, and we've never really seen this happening before. But this is obviously something that was always predicted. We know that black holes go through various active stages and sometimes reawaken when, for example, they suddenly get a huge amount of mass they can absorb, producing enormous amounts of energy and becoming more massive in the process. But what's a little bit more unusual is the fact that in the last year or so, there's also been a lot of evidence for a lot more supermassive black holes than we actually expected in many of these distant regions. For example, we've discussed some of the previous discoveries in regards to so-called little red dots that seem to represent distant bright galaxies, mostly containing massive black holes and a lot of dust. And so in most cases, the observations here suggest a much higher number of very massive black holes than the scientists originally anticipated or predicted. Which basically raises the question, how exactly are they forming, where are they coming from, and more importantly, what's the main process that causes them to become so massive? So in essence here, it's just a little bit difficult to understand how they're able to grow so rapidly, so early on. But there's always been two main explanations. Either these black holes were already massive when the universe just began right after the Big Bang, and were thus created as supermassive black holes right in the beginning. This is basically the idea known as the direct collapse model. Or they were born from much smaller objects, possibly even as a result of really massive supernova, and eventually grew super fast to their current sizes. But the thing is, there was really no evidence for either one of these explanations. The only evidence researchers had was the observations that supermassive black holes already existed just a few 100 million years after the beginning of the universe. And based on current estimates, or specifically estimates of their growth, it would be practically impossible for them to acquire these enormous masses. And that's because of one intriguing principle. It's usually referred to as the Eddington limit. And it basically refers to the luminosity of a typical body, or essentially the brightness of, for example, a star. This concept was originally proposed by the famous Sir Arthur Eddington, the English astronomer who basically predicted nuclear fusion before we even discovered it. But more famously, he was the one who took the picture that eventually proved Einstein correct. So I guess in some sense, he kind of made Einstein who he was. If it wasn't for Eddington's experiment, Einstein would most likely never become famous. But one of his groundbreaking propositions was in regards to the limit of brightness. And this is in essence because we know that photons basically produce just a little bit of momentum. In other words, even though they have no mass, because they contain energy, they can also push on things just a little bit. That's of course why we have things like, for example, solar sails, which work in outer space. And so back in the days, Eddington proposed that, well, there's probably a brightness limit, because at some point, something can become so bright and produce so many photons that they're actually going to be producing so much push away from an object like a star that it's actually going to start losing mass, and the push from the photons is going to be higher than the star's gravity. And well, he was definitely right, because we've discovered so many stars out there that are practically at their Eddington limit. The most common example here is a typical Wolf-Rayet star, an extremely bright and an extremely hot star whose ridiculous brightness produces enormous solar winds, resulting in these stars losing huge amounts of mass really fast. Although in this case this is usually referred to as the Eddington factor, and that's because they're not really at that limit yet. Because if they were at that limit, they would just completely fall apart, turning into some kind of a nebula. But that's stars. With time we discovered black holes. And turns out that this is even more important for black holes, because despite the name, they're not really black. they do have accretion disks that produce enormous amount of brightness, and the accretion disks here seem to have a direct control over how fast these black holes are going to be growing. And specifically, if you have an extremely bright accretion disk that produces an enormous amount of light, all of this is going to be pushing away all of the mass away from the black hole, thus to some extent preventing it from growing. Whereas with a much smaller disk, more mass can fall into the black hole. This of course causes the accretion disk to grow in size and to eventually produce more brightness and thus a higher Eddington factor. And so at some point, most black holes can actually assume a kind of a balance, which is what we would call an Eddington limit. Here, in theory, there's going to be a limit between the momentum pushing the mass away coming from all of the photons in the accretion disk and the gravity from the black hole itself that tries to pull everything in. And so here we would call this an Eddington limit black hole. Alright, cool. Well, following this super long explanation, what are we actually talking about today? Well, today we're talking about this. LID 568, recently discovered by an international team by using Chandra X-ray telescope combined with the James Webb. And this is an example of a super Eddington limit black hole, or a super Eddington accreting black hole 1.5 billion years right after the Big Bang. That's actually the name of the paper. In other words, this black hole seems to be producing a lot more light than theoretically possible. It's brighter than it should be, or it produces way more photons than it should be producing, because we expect these photons to push all of the mass away from the black hole, thus preventing most of the accretion. Yet here, we observe something entirely different. This seems to be an extremely rare example that was discovered inside an early universe dwarf galaxy, where the material is absorbed at an extreme rate, 4,000% of the expected value, or essentially 40 times the Eddington limit. And that's of course the shock. Nobody has ever seen anything like this ever before. In essence, this means that this black hole is feeding on the matter 40 times faster than should be possible, which means that it's growing 40 times faster than predicted as well. And that's of course both good news and bad news for astronomers. Obviously, the good news here is that this finally provides us with actual physical evidence that black holes seem to be able to grow super fast, much faster than we thought possible in the beginning of the universe. Which means that when it comes to supermassive black holes really early on, we don't really need to have any more additional explanations or any more exotic theories, because this observation explains everything all at once. Black holes, unlike predicted, seem to be able to acquire huge amounts of mass really fast. In this case, we have observations coming from the black hole suggesting winds of 600 km per second, which implies very powerful nuclear-driven outflow, and the black hole itself is already more massive than Sagittarius A star, approximately 7.2 million solar masses. But there is, of course, that problem. The problem is explaining how it's able to do this. Because this was such a unique observation, researchers wanted to confirm that the observations from the Chandra telescope were actually showing us the reality by confirming this with infrared observations from the JWST. And the results do seem to actually match, which meant that the researchers here were left with a bit of a mystery. The mystery being that somehow this black hole had at least one episode of extremely fast growth that dramatically increased its mass, producing all of this extra luminosity. And more importantly, this potential is very common, and most black holes are very likely able to do this, independent of how they were born. But this study does not provide us with a more exact explanation. However, another study from last year possibly does. And this is actually a completely independent study based on computer simulations that essentially try to figure out how certain black holes are able to grow through these unusual bursty processes. And so let's briefly discuss this other study that potentially provides maybe one explanation, and actually a really good explanation. Here this is based on supercomputer simulations that show us what happens near the accretion disk, and especially as you get closer and closer to the central black hole. This is a study by Nicholas Kaz and his team. And so in this study, scientists decided to focus on ignoring the classical theory describing black hole accretion disks, and instead focused on relativistic frame dragging effects, which become even more prominent as you get closer and closer to the central black hole, because it basically starts to warp space-time around itself. And turns out that this relativistic frame dragging can potentially affect disks quite dramatically. They basically start to wobble and spin, with the inner regions even breaking apart, forming additional features and additional structures. And more importantly, sometimes they seem to break into pieces or even form two accretion disks, something researchers refer to as streamers, that basically destabilize the entire system, but also dramatically increase the accretion into the black hole, causing the black hole to basically swallow the entire disk in a very short period of time, usually just a few months. And so here the simulations show that this unusual cycle seems to happen quite a lot and causes the black holes to dramatically increase their feeding mechanism, making them consume way more mass all at once, dramatically increasing their mass, but also naturally increasing the overall brightness. And that's because a tremendous amount of energy is released in the process. And doing this study, they basically focused on explaining certain really bright quasars and why we actually observe so many unusual features coming from them. In some sense, this also explains the unusual super Eddington black holes and how some black holes can grow really fast in mere months. And so here it's the result of the accretion disk breaking into pieces and producing subdisks because of relativistic effects and frame dragging close to the black hole, which then in essence explains these powerful outflows and all of the excess energy we're observing. But that's of course just one potential explanation. We don't really know what's going on around this black hole, we just know that something is definitely going on and it's growing really fast, 40 times faster than anyone thought was possible. But obviously, because this is such an incredible discovery, we'll be coming back and talking more about this once there are some more clues, or someone else provides additional explanations, or even discovers something else incredible about this peculiar black hole. Until then, check out some of the previous videos on similar topics in the description below. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining a channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.